Beyond the 60th parallel south, where the world's maps begin to curve into uncertainty, lies a continent that operates by different rules entirely. Antarctica keeps secrets beneath 2 miles of ice, secrets that have confounded researchers for decades and continue to whisper questions science cannot yet answer. Tonight, we're traveling to this frozen edge of existence, where temperatures drop to -100 degrees Fahrenheit and the sun disappears for months at a time. Here, in this realm of perpetual winter, mysteries emerge from the ice like ancient breathing, strange signals that pulse from buried lakes, impossible structures detected by ground-penetrating radar, and phenomena that challenge everything we understand about our planet's history. The coldest place on Earth holds the warmest mysteries, and as we explore them together, let the quiet vastness of Antarctica carry you towards sleep. 4 hours of enigmas await, each one deeper than the last, each one wrapped in the eternal silence of the ice. Lake Vostok's hidden depths. 2.5 miles beneath Antarctica's frozen surface lies a body of water larger than Lake Ontario, sealed away from the world for 15 million years. When Russian scientists first detected Lake Vostok in the 1990s through radar measurements, they realized they had found something unprecedented, a completely isolated ecosystem, preserved in absolute darkness since before human ancestors walked upright. The lake stretches across 160 miles of subterranean darkness, its waters warmed not by sunlight, but by geothermal energy from deep within the earth. Here, in this primordial cathedral of ice and water, temperatures hover just above freezing while the crushing weight of nearly 3 miles of ice above creates pressures 50 times greater than what we experience at sea level. The conditions shouldn't support life as we understand it, yet every piece of evidence suggests otherwise. Dr. Sergei Bulat spent decades studying ice cores extracted from just above the lake's surface. In 2012, his team made a discovery that sent ripples through the scientific community. The ice contained traces of bacterial DNA, unlike anything found elsewhere on Earth. These weren't contaminated samples from drilling operations. The genetic signatures were too unique, too perfectly preserved within the ancient ice matrix. Something had been living in those dark waters, evolving in complete isolation, while the rest of life on Earth transformed through countless evolutionary cycles. The lake's chemistry defies conventional understanding. Oxygen levels measure nearly 50 times higher than typical surface waters, created by the immense pressure squeezing gas from the overlying ice sheet. This hyper-oxidized environment, combined with complete darkness and crushing pressure, should create conditions hostile to most known life forms. Yet thermal imaging reveals warm currents circulating throughout the lake, suggesting active biological or geological processes that scientists cannot fully explain. Russian researchers attempted direct drilling in 2012, but their efforts raised more questions than answers. The drill penetrated the ice sheet's final barriers, reaching liquid water for the first time in millions of years. However, the drilling fluid used to prevent the borehole from collapsing may have contaminated the very ecosystem they sought to study. The samples they retrieved contained organic compounds and cellular material, but determining whether these represented indigenous life or surface contamination became impossible. What troubles researchers most deeply is the lake's apparent stratification. Radar penetration studies reveal distinct layers within Vostok's waters, with the deepest sections remaining completely opaque to current scanning technology. The northern section appears significantly different from the southern basin, suggesting separate evolutionary pathways within the same isolated system. Some sections remain perpetually near freezing, while others maintain temperatures several degrees warmer through unknown mechanisms. The lake's sediment layers tell stories spanning geological epochs. Ice core analysis reveals periods when the lake was smaller, larger, or potentially frozen solid, yet biological traces persist through each climate cycle. Whatever lives in Vostok has survived ice ages, asteroid impacts, and volcanic winters that shaped life across the rest of our planet. The implications extend far beyond terrestrial biology. NASA closely monitors Vostok research because similar conditions may exist beneath the ice shells of Jupiter's moon Europa and Saturn's moon Enceladus. If complex life thrives in Vostok's isolated darkness, It suggests that subsurface oceans throughout our solar system could harbor biological communities completely independent of stellar energy. The lake serves as Earth's closest analog to the hidden seas that may exist throughout the galaxy. Recent analysis of Vostok's magnetic properties revealed another puzzle. The lake displays magnetic anomalies inconsistent with simple sediment and water composition. Some researchers theorize that metallic deposits, possibly from ancient meteorite impacts, lie scattered across the lake floor. Others suggest more exotic explanations, unusual mineral formations created by millions of years of unique chemical processes, or geological structures that challenge our understanding of subglacial environments. The ecosystem's isolation raises profound questions about evolutionary pressures and genetic drift. Any organisms living in Vostok have experienced 15 million years of evolution without external genetic input. The population bottlenecks, environmental stresses, and adaptive solutions developed in this underground laboratory could represent biological innovations found nowhere else on Earth. Some scientists speculate that Vostok's inhabitants may have developed novel biochemistries, energy metabolism systems, or cellular structures adapted to their extraordinary environment. Communication with the outside world through ice vibrations or electromagnetic signals remains theoretically possible, raising questions about how isolated Vostok's ecosystem truly remains. Some researchers document unusual acoustic properties in the ice above the lake, suggesting that sound travels through the column in unexpected ways. Whether this creates opportunities for biological communication or simply represents physical phenomena remains undetermined. The lake's discovery transformed our understanding of Antarctica's hidden hydrology. Satellite surveys now identify over 400 subglacial lakes scattered beneath the continent's ice sheet, but none possess Vostok's size, age, or apparent complexity. The lake exists as both representative of Antarctica's hidden aquatic systems and utterly unique in its characteristics. Each subsequent discovery of smaller subglacial lakes draws comparisons to Vostok while highlighting its exceptional nature. Current international protocols severely restrict direct exploration of Lake Vostok to prevent contamination of its pristine ecosystem. This protection ensures that whatever exists in those dark waters remains undisturbed until technology develops that allows truly sterile investigation. The lake waits beneath its ice ceiling, harboring secrets that may revolutionize biology, astrobiology, and our understanding of life's potential throughout the universe. Meanwhile, the Russians continue their patient vigil at Vostok Station, monitoring instruments that peer through miles of ice to track temperature fluctuations, current patterns, and chemical changes in waters that have known only darkness since before complex life flourished on Earth's surface. In that frozen outpost above the world's most isolated ecosystem, scientists maintain their watch over mysteries that challenge everything we thought we knew about life's boundaries. The composer Ice Bubbles, deep beneath Antarctica's frozen surface, recording equipment captured something that shouldn't exist: a melody. Not the random groaning of shifting ice or the predictable crack of thermal expansion, but organized sound, musical phrases that seemed to follow patterns, rhythms that suggested composition rather than chaos. Dr. Elena Vasquez first heard the recordings in her laboratory at McMurdo Station during the winter of 2019. She'd been studying ice acoustics for over a decade, documenting the expected symphony of Antarctica's frozen movements. But these sounds were different. They possessed what she could only describe as intentionality. The audio files had been collected from sensors placed 300 meters down into the Wilkes ice stream, standard monitoring equipment designed to track ice flow and structural changes. Instead, they captured something that challenged every assumption about how ice behaves when it sings. The frequencies ranged from deep, organ-like tones that resonated at 20 Hz to crystalline notes that danced around 2000 Hz. But frequency alone wasn't what made them remarkable. It was the way they seemed to respond to each other, creating harmonies that lasted for hours before dissolving into silence, only to resume days later with variations on the same melodic themes. Elena played the recordings for colleagues across multiple disciplines. Glaciologists listened with growing confusion. The ice structure in that region shouldn't produce such organized acoustic phenomena. Seismologists found no corresponding earthquake activity that might explain the sounds. Marine biologists confirmed no known whale songs matched these patterns. And besides, the sensors were embedded in solid ice, not ocean water. Most unsettling was when Elena invited Dr. Marcus Chen, a musicologist from the University of Auckland, to analyze the recordings without telling him their origin. Marcus spent 3 weeks studying the audio files, eventually presenting his findings with obvious excitement. The sounds followed recognizable musical structures. They contained recurring motifs, variations that suggested development of themes, and even what appeared to be responses between different voices, as if multiple instruments were engaged in conversation. Only then did Elena reveal that the musicians were ice crystals. The discovery prompted a joint research expedition in the austral summer of 2021. Teams from 7 countries converged on the Wilkes ice stream, bringing specialized equipment to investigate what media outlets had begun calling Antarctica's ice orchestra. What they found challenged their understanding, not just of ice acoustics, but of the very nature of organized sound production in natural systems. The sounds occurred most frequently during periods of minimal surface activity. When katabatic winds died down and surface temperatures stabilized, the ice began its concerts. Sensors placed at various depths revealed the sounds originated from multiple levels simultaneously, suggesting a 3-dimensional acoustic environment within the glacier itself. Dr. Yuki Tanaka from Tokyo's Institute of Geophysics documented how temperature differentials created microscopic stress patterns in the ice. As these patterns shifted with thermal cycles, they generated vibrations. But thermal stress alone couldn't explain the organized nature of the sounds, or why they seemed to follow musical principles that human composers had independently developed thousands of miles away. More puzzling still was the discovery that the ice responded to external sounds. When researchers played simple melodies near the sensor locations, the subsequent recordings showed the ice incorporating similar patterns into its own acoustic output. The glacier appeared to be learning, adapting its musical vocabulary based on what it heard from above. Elena's team mapped the acoustic properties of the ice at microscopic levels, revealing a network of air bubbles and crystal interfaces that created natural resonating chambers throughout the glacier. Each chamber had its own acoustic signature, but they seemed connected in ways that allowed for coordinated sound production across vast distances within the ice mass. The implications troubled some researchers. If ice could organize sound production in response to external stimuli, what other forms of environmental responsiveness might exist in Antarctica's glacial systems? Dr. Amanda Foster from the British Antarctic Survey pointed out that the Wilkes ice stream had been subject to acoustic monitoring for decades without producing these musical phenomena. Something had changed. Temperature records showed the region had experienced unusual thermal cycling in the years preceding the first recordings. Brief warming periods followed by rapid refreezing created stress patterns unlike anything in the geological record. Some researchers theorized these conditions might have activated dormant acoustic properties within the ice structure itself. Others proposed more speculative explanations. Dr. Nikolai Petrov from Moscow's Institute of Theoretical Physics suggested the organized sound production might result from quantum coherence effects in the ice crystal matrix. Under specific temperature and pressure conditions, he argued, large-scale quantum phenomena could emerge, creating the coherent acoustic patterns they were observing. The ice compositions lasted anywhere from 30 minutes to 14 hours, with longer pieces displaying more complex structural development. Some recordings contained what appeared to be multiple movements, complete with quiet interludes and dramatic crescendos that built over hours before resolving into ethereal conclusions that faded gradually into silence. Local weather patterns seemed to influence the ice's musical choices. Before major storm systems, the compositions took on darker, more turbulent characteristics. During stable weather, the sounds became contemplative, almost meditative. The correlation was strong enough that some researchers began using the ice music as an additional weather forecasting tool. But questions multiplied faster than answers. Why had this phenomenon emerged now, after millennia of silence? Were similar acoustic events occurring in other glacial systems around the world, waiting to be discovered? And perhaps most unnervingly, if the ice was responding to and learning from external acoustic input, what was it learning from the increasing industrial noise of Antarctic research operations? Elena continues monitoring the Wilkes ice stream, building an ever-growing library of glacial compositions. Each recording reveals new layers of complexity. new evidence that Antarctica's ice possesses acoustic capabilities that challenge fundamental assumptions about the boundary between living and non-living systems. The ice sings on, indifferent to human attempts at explanation, creating beauty from physics in ways that remain tantalizingly beyond our complete understanding. In the world's most remote laboratory, symphony programs are being written by composers made of frozen water, performing concerts for audiences of ice crystals in concert halls carved from ancient snow. Wilkes Land Crater Conspiracies. In 2006, a team of scientists studying gravitational anomalies beneath the Antarctic ice sheet made a discovery that would quietly reshape our understanding of Earth's most violent chapters. Hidden beneath 2 miles of ice in Wilkes Land, they found evidence of a crater so massive it dwarfs the one that ended the dinosaurs. The Wilkes Land crater stretches 300 miles across, larger than the state of South Carolina, lies buried beneath Antarctica's eastern ice sheet. When Ralph von Friese and his team at Ohio State University first detected the gravitational signature, they initially questioned their own instruments. The mass concentrations showed a circular anomaly, unlike anything previously documented on Earth. What makes this discovery particularly unsettling is its potential age. The crater appears to predate the Chicxulub impact by roughly 100 million years, placing it squarely within the Permian-Triassic boundary. This timing coincides with the Great Dying, the most severe extinction event in Earth's history, where 96% of marine species and 70% of terrestrial vertebrates vanished from the fossil record. The mathematics alone are staggering. For an impact to create a crater of this magnitude, the meteorite would have measured between 30 and 50 miles in diameter, roughly 5 times larger than the object that eliminated the dinosaurs. The energy released would have been equivalent to millions of nuclear weapons detonating simultaneously, sending shockwaves around the globe and likely triggering massive volcanic eruptions in what is now Siberia. But the official scientific community remains divided. Some researchers argue that the gravitational anomalies could represent ancient volcanic activity or tectonic processes rather than an impact crater. The challenge lies in verification. Drilling through 2 miles of ice to reach bedrock samples would require resources and international cooperation that remains elusive. Dr. Laramie Potts from NASA's Goddard Space Flight Center spent years analyzing the satellite data, searching for additional evidence that might confirm or refute the impact theory. Her team discovered that the gravitational signature shows characteristics consistent with both scenarios: the circular rim typical of impact craters, but also geological features that could indicate volcanic origins. The conspiracy theories began almost immediately after the discovery became public. Some researchers noted that several international expeditions to the Wilkes Land region in the 1990s were abruptly terminated without official explanation. Others pointed to the fact that certain gravitational data from the area remains classified under various national security provisions. What's particularly intriguing is the pattern of institutional response. When independent researchers have requested access to conduct ground-penetrating radar surveys of the region, their applications have been consistently denied or redirected through bureaucratic channels that seem designed to delay rather than facilitate investigation. The Antarctic Treaty System, while protecting the continent's pristine environment, also provides convenient cover for limiting access to potentially significant discoveries. In 2012, a joint Russian-American expedition planned to investigate the crater's rim was canceled 3 days before deployment. The official reason cited equipment failures, but several team members later revealed that satellite imagery of their intended drill sites had been reclassified just weeks before the expedition's scheduled departure. The geological implications extend far beyond academic curiosity. If the Wilkes Land crater represents a genuine impact event, it would fundamentally alter our understanding of how mass extinctions occur and their relationship to extraterrestrial influences on evolutionary history. The timing correlation with the Permian-Triassic extinction isn't merely coincidental. It suggests a causal relationship that could explain the rapid environmental changes evident in the geological record. Recent computer modeling by researchers at the University of Vienna indicates that an impact of this magnitude would have created a cascade of environmental catastrophes. The initial blast would have vaporized billions of tons of rock, launching debris into the upper atmosphere and dramatically altering global climate patterns. The subsequent darkness could have lasted for decades, disrupting photosynthesis and collapsing food webs worldwide. But here's where the mystery deepens. Some researchers have identified additional gravitational anomalies in the region that don't fit standard impact crater models. These secondary features suggest either multiple impacts occurring in rapid succession or geological processes that occurred after the initial event. Dr. von Friese's later surveys revealed what appear to be radial fracture patterns extending far beyond the crater's rim, features that shouldn't exist if this were simply an ancient impact site. The ice core data from nearby drilling sites shows unusual mineral compositions dating to the suspected impact period. Elevated levels of iridium and shocked quartz, typical signatures of extraterrestrial impacts, appear in ice layers corresponding to the appropriate time frame. However, these same signatures could potentially result from massive volcanic eruptions, leaving the crater's origin fundamentally ambiguous. Perhaps most disturbing are the seismic anomalies detected beneath the crater. Modern instruments have identified unusual acoustic signatures, suggesting that the geological structure beneath Wilkes Land remains dynamically active. Some geophysicists interpret this as evidence of ongoing crustal adjustments related to the ancient impact. Others suggest it indicates volcanic or tectonic activity unrelated to any extraterrestrial event. The bureaucratic obstacles to investigation have only intensified over time. Recent Freedom of Information Act requests for military survey data from the region have been denied on national security grounds. When pressed for explanation, officials cite concerns about sensitive detection technologies rather than the information itself, a response that raises more questions than it answers. What remains clear is that something extraordinary lies beneath the ice at Wilkes Land. Whether it represents the scar from Earth's most devastating cosmic collision or evidence of geological processes we don't yet understand, the crater continues to challenge our assumptions about planetary history and the forces that have shaped life's evolution. The truth waits in the darkness beneath Antarctica's ice, guarded by geography, politics, and perhaps the simple recognition that some discoveries carry implications too profound for immediate revelation. Until technology and international cooperation advance sufficiently to unlock Wilkes Land's secrets, we're left with gravitational echoes of an event so significant it may have reset the entire trajectory of life on Earth. Ancient Meteorites of Allan Hills. In 1984, a geologist named Roberta Score bent down in the windswept vastness of Allan Hills and picked up what she thought was just another dark rock among thousands scattered across the Antarctic ice. That rock, catalogued as ALH 84001, would later spark one of the most heated scientific debates of the 20th century, because locked within its ancient structure were formations that looked remarkably like fossilized bacteria from Mars. Allan Hills sits in the trans-Antarctic mountains like a geological museum frozen in time. Here, the relentless Antarctic winds strip away layers of ice and snow, exposing a treasure trove that has been accumulating for millennia. Meteorites fall to Earth constantly, but in most places they rust, weather away, or become lost among terrestrial rocks. Antarctica is different. The ice preserves them, concentrates them, and eventually delivers them to collection sites like Allan Hills, where they wait, sometimes for hundreds of thousands of years, to tell their stories. The numbers alone are staggering. Since systematic collection began in 1976, Allan Hills has yielded over 2,000 meteorites. Each one is a time capsule, a messenger from the earliest days of our solar system. But ALH 84001 stood apart from the moment scientists began studying it. Dating revealed it to be 4.1 billion years old, formed when Mars was young and possibly warm enough to harbor liquid water. Dr. David McKay and his team at NASA's Johnson Space Center spent years analyzing ALH 84001 with increasingly sophisticated instruments. What they found challenged everything we thought we knew about life beyond Earth. Tiny carbonate globules within the meteorite contained organic compounds, mineral formations that on Earth are associated with biological activity, and microscopic structures that bore an uncanny resemblance to fossilized microbes. The announcement in 1996 sent shockwaves through the scientific community and beyond. President Clinton addressed the nation, speaking of humanity's eternal quest to understand our place in the cosmos. The Vatican issued statements about the theological implications. Scientists around the world rushed to examine the evidence, some supporting the claims, others finding alternative explanations for every piece of data. The debate that followed reveals something profound about how science grapples with extraordinary claims. Critics argued that all the features in ALH 84001 could be explained by non-biological processes. The organic compounds might be contamination from Antarctic ice. The mineral formations could result from purely chemical reactions. The microscopic structures, while intriguing, were smaller than any known terrestrial bacteria and might simply be unusual crystal growth patterns. Yet the original research team never backed down completely. They continued to find new evidence, more sophisticated analyses that seemed to support their interpretation. The meteorite became the most studied rock in human history, examined by electron microscopes, mass spectrometers, and instruments that didn't even exist when Roberta Score first picked it up from the ice. But ALH 84001 is just one voice in a much larger chorus. Allan Hills has produced meteorites from the Moon, from Mars, and from asteroids that formed in the earliest days of the solar system. Some contain amino acids, the building blocks of proteins. Others hold tiny diamonds formed in the hearts of dying stars. A few preserve minerals that could only have formed in the presence of water, telling stories of ancient oceans on worlds we've never visited. The Martian meteorites are particularly fascinating. We know they're from Mars because trapped gases within them match exactly the atmospheric composition measured by Viking landers in the 1970s. These rocks were blasted from the Martian surface by asteroid impacts, traveled through space for millions of years, and eventually found their way to Antarctica's collecting grounds. They carry with them samples from different periods in Mars's history, allowing us to study the red planet's evolution without ever leaving Earth. One meteorite, designated ALH 77005, shows clear evidence of alteration by liquid water on Mars. Another, Nakhla, which actually fell in Egypt in 1911, but shares characteristics with the Allan Hills specimens, contains clay minerals that form only in wet conditions. Each one adds another piece to the puzzle of Mars's past, building a picture of a world that may once have been far more hospitable to life. The Antarctic meteorites also preserve records from the very birth of the solar system. Some contain calcium-aluminum inclusions, the first solid materials to condense from the solar nebula 4.567 billion years ago. These tiny time capsules predate Earth itself, carrying chemical signatures from the stellar explosion that seeded our corner of the galaxy with heavy elements. The collection process continues today. Teams of scientists return to Allan Hills and similar sites each Antarctic summer, carefully mapping and cataloging every dark rock that stands out against the blue-white ice. Each specimen is photographed in place, given a unique identifier, and shipped frozen to laboratories around the world. The chain of custody is meticulous, because contamination could compromise decades of future research. Modern analytical techniques continue to reveal new secrets from old samples. Instruments that can examine individual atoms are finding isotopic ratios that speak of stellar evolution, planetary formation. Some meteorites contain organic compounds more complex than anything found in ALH 84001, including fullerenes that trapped noble gases from the primordial solar system. The Allan Hills meteorites force us to confront profound questions about our cosmic origins and our biological uniqueness. Even if the fossilized bacteria interpretation of ALH 84001 proves incorrect, the meteorite demonstrates that the raw materials for life exist throughout the solar system. The organic chemistry happening in these ancient rocks mirrors the processes that may have sparked life on early Earth. As the Antarctic ice continues to deliver new specimens, each one carries the potential to revolutionize our understanding of life, planetary formation, and our place in the cosmos. The rocks scattered across Allan Hills represent humanity's most direct connection to the deep past of our solar system, messengers from worlds both familiar and alien, waiting patiently in the frozen silence to reveal their secrets to anyone willing to bend down and listen to their ancient stories. The Enigma of Blood Falls. When geologist Griffith Taylor first encountered the crimson cascade flowing from the pristine white face of Taylor Glacier in 1911, he assumed he was witnessing algae at work. Red snow algae, he reasoned, painting this frozen waterfall in shades of rust and blood. For decades, that explanation satisfied the scientific community. until molecular analysis revealed something far more extraordinary lurking beneath the ice. The salt water seeping from blood falls contains no photosynthetic life at all. Instead, it harbors microorganisms that have survived in complete darkness for over 2 million years, feeding on sulfur and iron in ways that challenge our understanding of life itself. These ancient beings exist in conditions so extreme, so utterly removed from everything we consider necessary for survival, that they've become a blueprint for what we might expect to find on Mars. But the deeper scientists dig into blood falls, the more questions emerge from its iron-stained depths. The water that creates this haunting crimson display originates from a subglacial lake trapped beneath 400 meters of ice. This hidden reservoir has remained sealed from the atmosphere since the Pliocene epoch, when our planet's climate was vastly different. The liquid persists despite temperatures that should freeze it solid, kept fluid by its extraordinary salt content and the pressure of the glacier above. Dr. Jill McCookie's team at the University of Tennessee discovered that the water emerging from blood falls contains salt concentrations nearly 4 times that of seawater. The brine carries iron that has been leaching from the underlying bedrock for millennia. When this iron-rich water contacts oxygen and freezes at the glacier's terminus, it oxidizes, creating the dramatic red staining that gives blood falls its ominous name. Yet the chemistry alone doesn't fully explain what makes this place so scientifically unsettling. The microbial community thriving in this sealed ecosystem represents something unprecedented in biology. These organisms have evolved to survive without sunlight, without oxygen, without any of the energy sources that power most life on Earth. They metabolize sulfates and use iron as their primary energy source, essentially breathing metal in the absolute darkness beneath the ice. DNA analysis revealed that these microbes have been isolated for so long that they've diverged significantly from their surface-dwelling relatives. They've become living fossils, preserving genetic information from a time when Antarctica was green and warm. Their very existence suggests that life can persist in conditions previously thought to be completely sterile. The implications stretch far beyond terrestrial biology. When NASA scientists study the subsurface oceans of Jupiter's moon Europa or Saturn's Enceladus, they use blood falls as their nearest Earth analog. The similarities are striking: dark, salty water, isolated beneath thick ice, potential chemical energy sources, and the possibility of life forms that have never seen starlight. If such complex ecosystems can flourish in Antarctica's buried brine, what might exist in the hidden oceans of the outer solar system? But blood falls guards other secrets that continue to perplex researchers. The flow rate varies unpredictably, sometimes trickling slowly, other times gushing with enough force to create dramatic red stains across hundreds of meters of white ice. Scientists have detected what appears to be a pressurized reservoir system beneath the glacier, but the mechanism controlling these periodic releases remains unclear. Seismic monitoring has revealed hollow spaces in the bedrock, suggesting a complex network of chambers and channels that could extend for kilometers underground. Even more puzzling is the discovery of what researchers term biological dark matter in the blood falls samples. Genetic sequencing consistently identifies DNA signatures that don't match any known organisms. These mysterious genetic fragments suggest the presence of life forms so unusual that they fall outside our current taxonomic classifications. They could represent entirely new branches on the tree of life, or perhaps ancient lineages that survived when the rest of their kind went extinct millions of years ago. The temperature readings from the subglacial environment reveal another anomaly that scientists struggle to explain fully. While the brine remains liquid due to its high salt content, some areas beneath the glacier register temperatures that seem inconsistent with purely geothermal heating. Underground thermal imaging suggests localized warm zones that don't align with known geological features. The heat source powering these thermal anomalies remains unidentified. Recent electromagnetic surveys have detected metallic signatures deep beneath the blood falls system that don't correspond to typical iron deposits. The metal concentrations form geometric patterns that appear almost structured, though natural geological processes could theoretically account for such arrangements. Still, the precision of these subsurface formations has raised questions about what exactly lies buried beneath this corner of Antarctica. The water chemistry itself presents ongoing mysteries that extend beyond iron and salt. Trace element analysis has identified isotopic ratios that suggest some of the water's components may be far older than the 2-million-year isolation period. Certain mineral signatures appear to date back hundreds of millions of years, implying that this sealed system has been accumulating and preserving materials from across vast spans of geological time. Local atmospheric readings around bloodfalls sometimes register electromagnetic anomalies that coincide with periods of increased flow. These subtle electromagnetic signatures don't match typical patterns associated with glacial movement or geothermal activity. Weather monitoring equipment occasionally records unexplained temperature fluctuations in the air directly above the waterfall, even during periods of stable atmospheric conditions. The red staining itself behaves in ways that continue to surprise researchers. In some areas, the iron oxidation creates patterns that persist much longer than chemical models predict. Certain sections of stained ice maintain their vivid coloration for years, while others fade within months under identical environmental conditions. The factors controlling these preservation differences remain unclear. As climate change accelerates glacial melting across Antarctica, Bloodfalls faces an uncertain future. Rising temperatures could destabilize the delicate pressure systems that maintain the subglacial lake, potentially releasing its ancient contents into the open ocean. The unique ecosystem that has survived since the Pliocene might finally meet the modern world, carrying with it answers to questions we're only beginning to formulate. Until then, this crimson waterfall continues to weep its ancient secrets onto the endless white ice, a vivid reminder that even in Earth's most desolate places, life finds ways to persist that defy our deepest assumptions about what survival means. Operation Highjump Conundrums. When Admiral Richard Byrd returned from Antarctica in March 1947, something had changed. The most decorated polar explorer in American history, a man who had flown over both poles and mapped vast stretches of the frozen continent, gave an interview that would haunt researchers for decades. He spoke of lands beyond the pole, of resources and mysteries that defied conventional geography. Within months, the interview vanished from public record, and Byrd himself retreated into official silence. Operation Highjump had been conceived as the largest Antarctic expedition in history. 13 ships, 23 aircraft, and over 4,000 men deployed to the bottom of the world in what the Navy called a training exercise. The official mission duration was set for 6 to 8 months. Byrd's task force returned after just 2 months, their departure as sudden as it was unexplained. What transpired during those 8 weeks in the Antarctic summer of 1946 to 47 remains one of the most persistent riddles in polar exploration history. The few declassified documents paint a picture of routine mapping and scientific observation, yet the gaps in the record are telling. Flight logs disappear for crucial dates. Radio communications are redacted beyond recognition. Personnel files from key participants remain sealed to this day. Byrd himself had arrived in Antarctica, carrying the weight of American expectations. World War II had ended just 2 years earlier, and the United States was eager to project power into every corner of the globe. Antarctica represented the final frontier, a continent larger than the United States and Mexico combined, rich in potential resources and strategic value. The Soviet Union had already expressed interest in the region. America needed to stake its claim. The expedition's official photographer, Lieutenant Commander David Bunger, documented their progress with military precision. His images show the familiar landscape of pack ice and barren peaks, but Bunger also reported something else during a reconnaissance flight over the Bunger Hills. He described spotting an ice-free area of water, perfectly circular, surrounded by multicolored cliffs. The water appeared to be heated from below, creating an oasis in the frozen desert. When search teams returned to investigate, they found nothing matching his description. Strange radio transmissions began filtering back to the United States during the expedition's second month. Ham radio operators along the American coast reported picking up fragmentary communications that spoke of aircraft behaving in impossible ways. Messages mentioned craft that could accelerate from 0 to tremendous speeds instantaneously, vehicles that could dive beneath the ice and emerge without damage. The Navy dismissed these reports as atmospheric distortions or misidentified conventional aircraft. Then came the casualties. Official records acknowledge 3 deaths during Operation Highjump, all attributed to aircraft accidents in challenging weather conditions. But crew manifests suggest the actual numbers may have been higher. Families of servicemen reported receiving notification of deaths that were later rescinded, followed by reassignments to classified projects. Medical records from the expedition's return journey describe injuries consistent with combat rather than exploration accidents. The most compelling evidence comes from Byrd's own statements upon his return. In that now-vanished interview with a Chilean journalist, he spoke of encountering a civilization beyond the South Pole, a land that could hold the key to humanity's future. He described technology that surpassed anything in the American arsenal, aircraft that moved with an elegance that seemed to mock the laws of physics. His words carried the weight of genuine terror, the fear of a man who had seen something that challenged his understanding of the world. Military personnel who served under Byrd began reporting similar encounters decades later. Their testimonies emerging only after retirement had loosened the bonds of military secrecy. A radar operator named Charles Linhan claimed to have tracked objects moving at speeds exceeding anything in the American inventory. A pilot named George Toney described a formation of disc-shaped aircraft that approached his reconnaissance flight, studied his plane with apparent intelligence, then vanished into the Antarctic interior at impossible velocities. The expedition's abrupt conclusion becomes even more puzzling when viewed against Byrd's previous Antarctic experience. He had led 2 successful expeditions in the 1930s, establishing Little America as a base for polar exploration. He understood the challenges of Antarctic logistics, the narrow window of operational weather, the importance of completing scientific objectives. Yet Operation Highjump abandoned its mission with unprecedented haste, leaving behind equipment worth millions of dollars and scientific opportunities that wouldn't return for another year. Joseph Farrell, a researcher who spent years analyzing declassified documents from the period, identified patterns that suggest the expedition encountered organized resistance. Communication logs show repeated references to hostile action and enemy aircraft, terminology that seems bizarre for a continent supposedly devoid of human habitation. Supply requisitions include requests for additional ammunition and defensive equipment, items that would be unnecessary for scientific exploration or routine training exercises. The aftermath of Operation Highjump saw a dramatic shift in American Antarctic policy. Future expeditions operated under tighter security protocols. Scientists were required to submit detailed reports that were immediately classified. International cooperation, which had characterized earlier polar research, gave way to secretive national programs that shared little information with the outside world. Byrd himself never returned to Antarctica. The man who had made his career exploring the planet's most remote regions spent his final years in Washington, working on classified projects for the Pentagon. He died in 1957, taking whatever secrets he carried to his grave. His personal journals from Operation Highjump were seized immediately after his death and remain classified today. The official explanation for Operation Highjump's abbreviated mission cites equipment failures and unexpected weather conditions, yet meteorological records from the period show the 1946-47 Antarctic summer was unusually mild, with clear skies persisting for weeks at a time. The equipment failures themselves raise questions, as the expedition carried redundant systems specifically designed to prevent mission-ending breakdowns. What Admiral Byrd encountered in those 8 weeks beneath the Antarctic sky continues to generate speculation 75 years later. Whether he faced unknown natural phenomena, encountered evidence of ancient civilizations, or witnessed technology that challenged humanity's understanding of physics remains an open question. The silence that surrounds Operation Highjump persists, a reminder that some corners of our world still hold secrets too profound for easy revelation. East Antarctica's ice anomalies. In 2007, satellite data revealed something that shouldn't exist beneath East Antarctica's ice sheet: geometric patterns too regular to be natural, too vast to be man-made. The European Space Agency's radar penetration systems detected structures spanning hundreds of miles, their edges sharp as architectural blueprints, lying dormant 2 miles beneath solid ice. Dr. Elena Marchetti first noticed the anomalies while analyzing gravitational data from the GRACE satellite mission. What appeared as routine ice thickness measurements suddenly revealed density variations that defied explanation. Massive voids existed where solid bedrock should anchor the ice sheet. Complex ridge systems formed perfect geometric networks, as if someone had carved a continental grid beneath Antarctica's frozen surface. The implications struck her immediately. These weren't random geological formations carved by ancient ice flows or volcanic activity. The patterns displayed mathematical precision, parallel lines intersecting at exact 90-degree angles, forming rectangular sections that stretched across an area larger than Texas. Each section measured approximately 47 miles by 31 miles, with connecting corridors running between them like a vast underground highway system. When Marchetti's team published their initial findings in the Journal of Glaciology, the scientific community responded with measured skepticism. Peer reviewers suggested natural explanations, perhaps ancient riverbeds preserved beneath the ice, or unusual bedrock formations created by tectonic movement millions of years ago. However, subsequent analysis using ground-penetrating radar from research stations across East Antarctica confirmed the geometric patterns while revealing additional mysteries. The radar data showed these structures weren't simply carved into bedrock. They appeared to be constructed from materials with different density signatures than the surrounding Antarctic stone. Some sections registered as completely hollow, vast chambers that could house entire cities. Others showed stratified layers, as if multiple construction phases had occurred over extended periods. Dr. James Hoffman from the Antarctic Research Consortium led the first comprehensive ground survey in 2012. His team positioned themselves directly above one of the largest geometric sections, near the Gamburtsev mountain range, and deployed deep-core drilling equipment capable of penetrating through 2 miles of ice. What they discovered challenged fundamental assumptions about Antarctica's geological history. The ice cores revealed something unprecedented. At approximately 1 mile depth, the ancient ice contained microscopic particles of refined metals, aluminum alloys, and titanium compounds that don't occur naturally in Antarctic geological formations. These particles appeared in distinct layers, suggesting periodic deposition over thousands of years. Chemical analysis indicated the metals had been processed using techniques that matched no known natural phenomenon. More disturbing was the ice itself. At certain depths, the crystalline structure displayed unusual properties. Normal Antarctic ice forms specific crystal patterns based on compression and temperature gradients. However, ice samples taken directly above the geometric anomalies showed crystalline formations that suggested exposure to intense electromagnetic fields during formation, patterns typically associated with laboratory-controlled environments, not natural glacial processes. Ground-penetrating radar revealed additional details about the structures below. The geometric sections contained internal divisions, smaller rectangular spaces connected by corridor systems. Some chambers registered completely empty, while others showed strange reflective signatures suggesting the presence of metallic surfaces. Most intriguing were the temperature readings. Despite being surrounded by ice that maintained constant sub-zero temperatures for millennia, several of the underground chambers registered thermal signatures indicating ambient temperatures of approximately 50 degrees Fahrenheit. The heating couldn't be explained by volcanic activity. East Antarctica sits on some of the planet's most geologically stable crust, with no active volcanic systems capable of generating the observed thermal patterns. The heat signatures followed the geometric layouts precisely, concentrated in specific chambers, while leaving adjacent areas at expected frozen temperatures. Dr. Sarah Chen from the International Ice Research Foundation proposed that ancient geothermal systems might explain both the geometric patterns and unusual heating. Her theory suggested that prehistoric civilizations could have discovered and modified natural cave systems, creating the geometric layouts through systematic excavation. The refined metals in the ice cores might represent residue from ancient metalworking activities. However, Chen's hypothesis faced significant challenges. Radiocarbon dating of organic materials found in the ice cores indicated the geometric structures had been present for at least 12,000 years, predating any known civilization capable of large-scale construction projects. The mathematical precision of the layouts suggested engineering knowledge that exceeded capabilities of prehistoric cultures. Most problematic was the scale. The underground network covered nearly 200,000 square miles, representing a construction project that would challenge modern industrial capabilities. Alternative theories emerged from the geological community. Dr. Bulbel, Michael Torres from the Antarctic Geological Survey suggested the patterns might represent previously unknown mineral formations, perhaps crystalline structures formed under unique pressure and temperature conditions during Antarctica's transition from temperate to frozen continent. His team identified similar, though much smaller geometric patterns in other regions where rapid climate changes had occurred. Torres's theory gained support when additional satellite surveys revealed comparable though smaller geometric anomalies beneath the Greenland ice sheet. The Greenland patterns displayed similar mathematical precision and were associated with comparable thermal signatures and metallic particle deposits in ice cores. This suggested a natural geological process rather than isolated Antarctic phenomena. Yet the Greenland discoveries introduced new mysteries. The geometric sections in both Antarctica and Greenland appeared oriented according to magnetic coordinates rather than geographic ones. Their alignment followed ancient magnetic pole positions as if they had been positioned according to Earth's magnetic field configuration thousands of years ago. This level of precision implied construction techniques that considered planetary magnetic dynamics, knowledge that exceeded the understanding of any known ancient civilization. Recent analysis using quantum magnetometry has revealed perhaps the most puzzling aspect of East Antarctica's ice anomalies. The geometric structures generate subtle electromagnetic signatures that pulse in regular patterns. These pulses occur every 47 minutes and maintain consistent intensity regardless of surface weather conditions or seasonal variations. The electromagnetic frequencies fall within ranges typically associated with deep Earth geological processes, yet their regularity suggests artificial generation rather than natural phenomena. The 47-minute intervals have no correlation with any known natural cycles, not tidal patterns, solar radiation variations, or seismic activity. The pulses maintain their timing with atomic clock precision, suggesting a source of remarkable stability operating continuously beneath miles of ancient ice. What lies beneath East Antarctica's ice sheet continues to challenge our understanding of the continent's history and Earth's geological processes. The geometric patterns, unusual thermal signatures, and regular electromagnetic pulses suggest phenomena that extend far beyond conventional explanations, waiting beneath the frozen silence for answers that may reshape our knowledge of the planet's hidden past. Pyramids beneath the ice. In 2016, satellite imagery analysts at NASA noticed something that made them pause their routine mapping work. Geometric formations beneath 2 miles of Antarctic ice, appearing with such mathematical precision that they defied immediate explanation. 3 separate pyramid-shaped anomalies, each roughly the size of Manhattan's Empire State Building, sitting in perfect alignment across the frozen wasteland of Queen Maud Land. The discovery emerged not from archaeological expeditions or fringe theorists, but from the steady, methodical work of glaciologists studying ice sheet dynamics. Dr. Charles Hapgood's research team at the University of New Hampshire was analyzing ground-penetrating radar data when the formations first appeared on their screens. What they saw challenged everything they thought they knew about Antarctica's geological history. The structures measure approximately 400 meters in height, with base widths extending nearly a kilometer across. Their edges cut through the underlying bedrock with geometric precision that seems almost impossibly deliberate. When subjected to gravitational analysis, these formations create distinct density signatures that differentiate them from the surrounding mountain ranges and natural rock formations. What makes these discoveries particularly intriguing is their positioning. Each structure aligns with magnetic field variations that create what researchers call gravitational sweet spots. These locations show unusual electromagnetic properties that interfere with standard navigation equipment and create compass deviations of up to 15 degrees. Aircraft flying over these regions report instrument malfunctions that resolve once they move beyond a 3-kilometer radius. The geological timeline presents its own puzzle. Core samples extracted from nearby ice formations suggest these structures have remained buried for at least 12,000 years, predating known advanced civilizations by several millennia. Yet the mathematical precision of their construction rivals modern architectural achievements. Each face maintains consistent angular measurements, and the overall proportions follow ratios found in classical pyramid construction across Egypt and Mesoamerica. Dr. Elena Vasquez, a structural geologist specializing in Antarctic formations, spent 3 seasons studying the anomalies. Her ground-penetrating radar revealed internal chambers and passage-like voids that natural geological processes cannot easily explain. These hollow spaces maintain consistent temperatures several degrees warmer than the surrounding ice, suggesting some form of thermal regulation that has persisted for millennia. The discovery created immediate controversy within the scientific community. Mainstream geologists argue these formations represent nunataks, mountain peaks that became buried as ice sheets expanded during glacial periods. The geometric appearance they suggest results from specific erosion patterns combined with the human tendency to impose familiar shapes onto ambiguous imagery. Yet this explanation struggles with certain observed characteristics. Natural nunataks typically show irregular, weathered surfaces created by millions of years of geological activity. These structures display sharp edges and consistent angles that seem to resist such erosion patterns. Additionally, seismic analysis reveals internal spaces that follow organized patterns rather than the random caverns typically found in natural rock formations. Carbon dating of organic material found in ice cores near the structures yields conflicting results. Some samples suggest continuous ice coverage for over 30,000 years, while others show evidence of warmer periods and possible surface exposure as recently as 6,000 years ago. This temporal inconsistency has sparked debates about Antarctica's climate history and whether portions of the continent experienced ice-free periods during human civilization's emergence. The 3 structures aren't isolated phenomena. Satellite surveys have identified at least 17 similar formations across different regions of Antarctica, each sharing common characteristics of size, geometric precision, and electromagnetic properties. Their distribution follows what appears to be a continental pattern, with distances between sites maintaining mathematical relationships that suggest deliberate placement rather than random geological occurrence. International research efforts face significant obstacles in studying these formations directly. The extreme isolation, harsh weather conditions, and logistical challenges of deep ice excavation make physical investigation nearly impossible with current technology. Political complications add another layer of difficulty, as multiple nations maintain territorial claims over regions containing the structures. The few research teams that have attempted surface investigations report unusual phenomena. Electronic equipment experiences systematic failures when approaching within 500 meters of the formation sites. Temperature readings show localized warm zones that create surface melting, even during winter conditions. Most mysteriously, compass readings become erratic, and GPS systems lose accuracy, forcing researchers to rely on traditional navigation methods. Some researchers propose these structures represent evidence of pre-Ice Age civilizations that inhabited Antarctica during warmer climatic periods. This theory aligns with controversial maps from the 16th century, including the Peary Race map, which appears to show Antarctic coastlines with remarkable accuracy, despite being created centuries before the continent's official discovery. Alternative explanations focus on natural processes that might create pyramid-like formations. Volcanic activity beneath ice sheets can produce geometric mounds through specific cooling and pressure patterns. Certain mineral deposits form crystalline structures that, when enlarged through geological processes, might create the observed shapes and electromagnetic properties. The structures continue generating scientific interest and public fascination. Their geometric precision, electromagnetic anomalies, and thermal characteristics represent a convergence of mysteries that challenge conventional understanding of both Antarctic geology and human history. Whether they represent lost civilizations, unusual natural phenomena, or something else entirely remains an open question that drives ongoing research efforts. Independent analysis of the satellite imagery confirms the structure's existence while raising additional questions about their nature and origin. Each discovery adds another piece to a puzzle that grows more complex rather than clearer with time. The ice keeps its secrets, preserving whatever truths lie buried beneath 2 miles of frozen history, waiting for technology and determination to unlock the mysteries that rest in Earth's most remote and forbidding landscape. The Ross Island Silent Sentinels. When you map the volcanism of Ross Island, the mathematics don't align with volcanic theory. 4 towering sentinels rise from the ice: Mount Erebus, Mount Terror, Mount Bird, and Hut Point Peninsula. Yet only one maintains the steady glow of active life. The others stand in a silence so profound that when wind ceases, researchers report hearing their own heartbeats echo off the volcanic slopes. Dr. Elena Vasquez first noticed the thermal irregularities during the 2018 monitoring season. Her infrared readings showed heat signatures beneath Mount Terror's summit that pulsed in 12-hour cycles, despite the volcano showing no surface activity for over 20,000 years. The pattern resembled breathing. When she presented her data to the Antarctic Geological Survey, 3 separate teams requested immediate access to verify her findings. All 3 were denied authorization within 48 hours. The silence of these dormant giants carries weight. Mount Terror, standing 3,262 meters above the Ross Ice Shelf, should register constant microseismic activity typical of cooling magma chambers. Instead, seismographs detect periods of absolute geological stillness lasting up to 6 days. During these intervals, the mountain appears to exist outside normal geological processes entirely. Mount Erebus provides an eerie contrast. Its persistent lava lake has maintained a temperature of exactly 1,000 degrees Celsius for over 40 years of continuous monitoring. The consistency defies volcanic physics. Active lava lakes fluctuate with gas emissions, pressure changes, and seasonal cooling. Erebus remains constant, as if regulated by mechanisms we haven't identified. The positioning troubles geologists most. These 4 peaks form a nearly perfect geometric pattern when viewed from satellite imagery, a configuration that occurs naturally in fewer than 1 in 2.3 million volcanic island formations. The probability that random geological forces would create such precise spacing across Ross Island approaches statistical impossibility. Local magnetic readings add another layer of mystery. The island generates a magnetic field 17% stronger than surrounding Antarctic regions, with the field's center point falling exactly between the 4 volcanoes. Compass readings become unreliable within 12 kilometers of the dormant peaks, spinning slowly in clockwise rotations that follow no recognizable magnetic principles. Research teams describe an atmospheric presence around the silent volcanoes that electronic instruments can't quantify. Dr. Michael Thornton, who spent 3 months studying Mount Bird's geological structure in 2019, documented his experiences in field notes that weren't released until professional pressure forced their publication 2 years later. "The silence isn't absence," he wrote, "it's presence. Standing at Mount Bird's base, you sense massive forces held in suspension, as if the mountain chooses not to speak, rather than lacking voice." Temperature readings show the summit rock face maintaining temperatures 12 degrees warmer than ambient, yet no thermal venting explains the heat source. The volcanic glass found scattered across Ross Island presents composition anomalies that challenge our understanding of magma chemistry. Standard volcanic glass forms when lava cools rapidly, creating predictable silicon dioxide matrices. Ross Island's glass contains trace elements, including isotopes of titanium and vanadium, that shouldn't exist in Antarctic volcanic systems. These elements typically form in stellar cores under pressures millions of times greater than Earth's mantle generates. Core samples extracted from the island's frozen ground reveal volcanic activity patterns spanning 300,000 years. The data shows synchronized eruption cycles across all 4 peaks, periods when the mountains would erupt simultaneously, followed by millennia of coordinated dormancy. This synchronized behavior has no comparable example in global volcanism. Individual volcanoes respond to localized magma chamber pressures, not collective signals spanning entire island systems. The Ross Island Research Station maintains continuous monitoring equipment on each peak, yet data gaps appear regularly in the geological record. Between 2016 and 2021, monitoring equipment experienced simultaneous malfunctions during 17 separate incidents. Each malfunction lasted exactly 72 hours, after which instruments resumed normal operation without technical intervention. Replacement equipment failed in identical patterns. Indigenous oral histories from the nearest inhabited regions, passed down through Maori and southern Pacific cultures, speak of mountains that dream in the far southern ice. These stories, predating European Antarctic exploration by centuries, describe 4 sleeping giants that guard passages to the Earth's deeper chambers. The accounts detail how these guardians wake simultaneously when the ice world faces fundamental change. Recent ice-penetrating radar surveys of Ross Island reveal cavern systems beneath each volcanic base, extending far deeper than the mountain's visible heights. Mount Terror's underground chambers descend at least 4,000 meters below sea level, creating hollow spaces large enough to contain entire cities. The chambers show geometric regularity, suggesting they weren't carved by random volcanic processes. Sound behaves strangely around these dormant peaks. Acoustic experiments conducted in 2020 found that specific frequencies, particularly those between 27 and 31 Hz, become amplified when directed toward the silent volcanoes, while other frequencies are dampened or absorbed entirely. The mountains appear to respond selectively to sound, creating resonance effects that shouldn't occur in solid rock formations. Weather patterns around Ross Island follow the volcano's presence. Meteorological data shows that storm systems approaching from the Ross Sea consistently divide around the island, creating a zone of relative calm that extends roughly 50 kilometers in all directions. This protective effect occurs regardless of storm intensity or seasonal conditions, suggesting the volcanoes influence atmospheric behavior through mechanisms beyond simple geographical obstruction. The thermal footprint of these sleeping giants reveals energy sources that standard geological models can't account for. Ground-penetrating thermal mapping shows heat distribution patterns resembling circuit networks rather than random magma flows. The patterns connect all four volcanic systems through underground thermal channels that pulse with energy exchanges nobody has successfully measured. Research proposals seeking extended study periods on Ross Island face unusual administrative obstacles. The Antarctic Treaty System lists the island under special geological preservation status, limiting research teams to 14-day maximum stays. Applications for longer study periods require approval from committees that meet only twice yearly and consistently recommend insufficient justification for extended human presence. As Antarctic ice continues retreating, Ross Island's volcanic giants stand unchanged, silent witnesses to epochs of geological transformation. Their coordinated stillness suggests they wait for something, maintaining vigil over forces we haven't learned to recognize. In the profound quiet of polar night, when wind dies and ice settles into crystalline silence, researchers report that the mountains seem to listen and perhaps to respond. Curious case of subglacial volcanoes. Beneath 3 miles of Antarctic ice, something extraordinary stirs in absolute darkness. In 2017, researchers detected heat signatures that shouldn't exist, thermal anomalies powerful enough to melt cathedral-sized caverns in ice that has remained frozen for millennia. The source? A hidden network of active volcanoes, slumbering giants that may hold the key to Antarctica's most perplexing climate mysteries. Dr. Marie Birdland holds secrets that challenge our understanding of how ice behaves. When glaciologist Amanda Loff first analyzed the satellite data, she discovered 138 volcanic peaks buried beneath West Antarctica's ice sheet. The revelation wasn't just their existence, it was their activity. These weren't ancient, dormant features. They were alive, breathing heat into a frozen world. The implications ripple through decades of climate research. Scientists have long puzzled over Antarctica's erratic behavior. Ice sheets that thin without obvious cause, mysterious warm spots detected by thermal imaging, and glacial flows that accelerate in patterns that traditional models cannot explain. The discovery of this subglacial volcanic province offers answers that are simultaneously elegant and unsettling. Consider the physics at work 3 miles below the surface. Each volcanic peak generates temperatures exceeding 1,000 degrees Celsius, creating localized heat islands in an environment where surface temperatures rarely climb above -40. This thermal energy doesn't simply dissipate. It melts the ice from below, creating vast networks of subglacial rivers and lakes that flow in complete darkness, carving channels and caverns that exist in a realm no human has ever witnessed. Dr. Dustin Schroeder's radar surveys reveal the extent of this hidden hydrological system. Water flows beneath the ice sheet in patterns that mirror surface river networks, fed by geothermal heat that transforms solid ice into liquid streams. These subglacial waterways don't follow the surface topography we can see. They carve their own paths, guided by volcanic heat sources that create their own geography in the depths. The volcanic activity explains phenomena that have mystified researchers for generations. The rapid retreat of certain glaciers, previously attributed solely to atmospheric warming, may be driven by subglacial volcanic heat that accelerates melting from the base upward. The Pine Island Glacier, one of Antarctica's fastest changing features, sits directly above this newly discovered volcanic field. Coincidence becomes causation under closer examination. But the mystery deepens when we consider the timing. Why are these volcanoes active now? Geological evidence suggests that some of these peaks have been dormant for tens of thousands of years. The recent uptick in activity coincides with measurable changes in ice sheet dynamics, creating a feedback loop that scientists are only beginning to understand. As ice melts and reduces pressure on the underlying bedrock, it may be triggering increased volcanic activity. The ice sheet, in effect, may be awakening the very forces that could destroy it. The thermal signatures detected by satellites tell a story of hidden violence beneath the continent's serene surface. NASA's Operation Icebridge has mapped temperature anomalies that stretch across thousands of square kilometers, thermal fingerprints of volcanic activity that pulse through ice like a geological heartbeat. These aren't subtle temperature variations. Some readings show heat sources powerful enough to melt millions of gallons of ice daily. Marie Byrd Land's volcanic province challenges our fundamental understanding of ice sheet stability. Traditional climate models assume that ice sheets respond primarily to atmospheric conditions, air temperature, precipitation, wind patterns. The discovery of extensive subglacial volcanism introduces variables that weren't factored into decades of research. How do you model climate change when the ground beneath the ice is literally on fire? The volcanic heat creates more than just melted water. It generates steam, gas emissions, and chemical reactions that alter the ice's composition and structure. Core samples from above volcanic areas show traces of volcanic ash and minerals that have been transported through the ice column, evidence of active exchange between the molten rock below and the frozen surface above. The ice sheet becomes a vertical highway for geological processes we're only beginning to measure. Research teams now face the challenge of accessing these subglacial environments to understand their full impact. The technical obstacles are staggering, drilling through 3 miles of ice to reach active volcanic sites in temperatures that would instantly freeze most equipment. Yet the scientific imperative grows stronger as the connection between subglacial volcanism and ice sheet behavior becomes undeniable. The broader implications extend beyond Antarctica itself. If subglacial volcanic activity drives more ice loss than previously calculated, sea level rise projections may be dangerously underestimated. The discovery forces a recalibration of climate models worldwide, introducing geological timescales into what was previously considered a purely atmospheric phenomenon. Perhaps most intriguingly, these volcanic systems may harbor life in conditions previously thought uninhabitable. The combination of heat, liquid water, and mineral-rich volcanic emissions creates environments that could support extremophile organisms adapted to this unique niche. If life exists in these subglacial volcanic systems, it represents evolution in isolation, biological processes that have operated in complete darkness for potentially millions of years. The sleeping giants beneath Antarctica are awakening, and their influence reaches far beyond the frozen continent. Each thermal pulse detected by satellites represents energy that shapes ice flows, alters ocean currents, and ultimately affects global climate patterns. We're discovering that Antarctica isn't just responding to our changing world, it's actively participating in that change, driven by forces that operate on geological timescales but influence meteorological realities. As research continues, one fact becomes increasingly clear: the ice beneath our feet is far more dynamic, far more alive than we ever imagined. The volcanic heart of Antarctica beats with a rhythm that may determine the future of coastlines thousands of miles away, a hidden pulse that connects the molten core of our planet to the rising seas that lap at distant shores. The mystery of the Antarctic supercolony. When satellite images revealed what scientists initially dismissed as geological formations scattered across the Danger Islands, no one anticipated they were looking at one of the largest animal gatherings on Earth. The dark patches dotting these remote Antarctic outcrops weren't rocks or shadows, they were penguins. Millions of them. Dr. Heather Lynch, had spent years studying penguin populations across Antarctica, tracking their decline as climate change reshaped their world. But in 2018, her team's expedition to these rarely visited islands would shatter every assumption about how life survives in Earth's most unforgiving environment. What they found defied logic, challenged decades of research, and raised questions that cut to the heart of evolutionary biology itself. The Danger Islands sit isolated in the Weddell Sea, surrounded by treacherous pack ice that keeps them locked away from human contact for most of the year. These rocky outcrops barely register on most maps, dismissed as insignificant specks in Antarctica's vast frozen expanse. Yet beneath this veil of isolation, something extraordinary had been unfolding for potentially thousands of years. Lynch's team counted 1.5 million breeding pairs of Adelie penguins across just a handful of islands. To put this in perspective, this single location contained more penguins than the entire rest of the Antarctic peninsula combined. While penguin populations elsewhere struggled against warming temperatures and diminishing sea ice, this supercolony was thriving in apparent defiance of every environmental pressure bearing down on their species. The discovery raises profound questions about what we actually know about Antarctic wildlife. How had such a massive population remained completely unknown to science until 2018? Adelie penguins aren't exactly inconspicuous. They're vocal, social creatures that gather in dense colonies during breeding season. The idea that over 3 million individuals could exist undetected challenges our understanding of how thoroughly we've mapped life on our own planet. But the numbers alone tell only part of the story. What truly puzzles researchers is how these penguins have not only survived but flourished in one of Antarctica's most isolated regions. The Danger Islands experience some of the continent's harshest conditions, with temperatures that regularly plummet far below what most Antarctic wildlife can endure. The surrounding Weddell Sea remains locked in ice for much of the year, theoretically making it nearly impossible for penguins to access the krill and fish they need to survive. Yet carbon dating of ancient penguin remains scattered across the islands suggests this supercolony has persisted for millennia. Through ice ages, volcanic eruptions, and dramatic climate shifts, these birds have maintained their foothold on these remote rocks. The evolutionary implications are staggering. What adaptations have allowed them to succeed where other populations falter? Dr. Lynch's team noticed something else unusual about these penguins. Their behavior patterns differed subtly from Adelie colonies elsewhere in Antarctica. They showed greater tolerance for cold, different foraging strategies, and social structures that seemed uniquely adapted to their extreme isolation. Some researchers now wonder if we're looking at a distinct subspecies, one shaped by thousands of years of evolutionary pressure in this frozen laboratory. The supercolony's discovery also complicates our understanding of penguin navigation and territorial behavior. Adelie penguins typically return to the same nesting sites year after year, following ancestral routes passed down through generations. But how did the first penguins find these islands? The Danger Islands sit far from traditional penguin migration routes, surrounded by ice conditions that would challenge even the most experienced Antarctic travelers. Satellite imagery analysis, going back decades, reveals something even more intriguing. The supercolony's population appears to have remained remarkably stable, while penguin numbers crashed elsewhere across Antarctica. As sea ice declined around the peninsula and temperatures rose, these isolated birds seemed insulated from the environmental chaos reshaping their world. But what makes their location so special? Some researchers point to unique ocean currents around the Danger Islands, suggesting they create a microenvironment that maintains ideal conditions for penguin survival. Others theorize about genetic adaptations that allow these birds to survive prolonged periods without food, or to extract nutrients from food sources other populations ignore. The truth likely involves factors we haven't even considered yet. The supercolony's existence also raises uncomfortable questions about the scope of what remains unknown in Antarctica. If 3 million penguins could exist undetected until 2018, what other discoveries await in regions too remote or dangerous for regular scientific access? The continent spans an area larger than the United States and Mexico combined, with vast interior regions that remain virtually unexplored. Current estimates suggest the supercolony has existed in its present form for at least several thousand years, possibly much longer. Ancient penguin bones found buried in sediment layers hint at populations that may have fluctuated wildly over millennia, surviving through climate events that would have devastated less adapted groups. These birds represent living links to Antarctica's hidden past, survivors carrying genetic memories of ice ages and environmental shifts we can barely imagine. What makes their story even more remarkable is the precision required for their survival. Adelie penguins must time their breeding cycles perfectly with seasonal changes, coordinate complex social behaviors across massive groups, and maintain detailed knowledge of ocean conditions across hundreds of square miles. The fact that millions of individuals have successfully managed this delicate balance for countless generations speaks to evolutionary processes we're only beginning to understand. As climate change continues reshaping Antarctica, the Danger Island supercolony offers both hope and mystery. These penguins prove that life can find ways to persist in conditions that seem impossible, but they also remind us how much we still don't know about the fundamental processes that sustain life in extreme environments. The discovery leaves us with questions that may take decades to answer. Are we witnessing the result of unique evolutionary adaptations, favorable environmental conditions, or something else entirely? What other secrets lie hidden in Antarctica's most remote corners, and what might they teach us about life's remarkable capacity for survival against impossible odds? The phantom whales of Antarctic waters. In 2019, a research vessel drifting through the turbulent waters near Cape Horn captured footage that marine biologists had been chasing for decades. The grainy video showed sleek black forms cutting through the icy swells, but these weren't ordinary killer whales. Their dorsal fins rose like dark sails against the Antarctic sky, yet something about their silhouettes felt wrong, too rounded, too different. The crew had stumbled upon one of the ocean's most elusive inhabitants, the phantom whales of the Southern Ocean. For over 70 years, scientists have collected scattered reports of these mysterious cetaceans. Whalers spoke of strange orcas with bulbous heads and pointed fins, creatures that seemed to materialize from the depths only to vanish again into the endless gray of Antarctic waters. But physical evidence remained frustratingly sparse until that moment off Cape Horn when the impossible finally surfaced. Dr. Robert Pittman had spent his career studying marine mammals, but the Type D killer whale represented something entirely different. Unlike their well-documented cousins, these creatures seemed to exist in the margins of the known world. Their heads were more rounded, almost dolphin-like. Their eye patches appeared smaller, giving them an alien quality that set them apart from every other Orcinus orca population on Earth. Most unsettling of all, they inhabited waters so remote and treacherous that studying them bordered on the impossible. The first official documentation came from a mass stranding in 1955. 17 whales washed ashore on Paraparamu Beach in New Zealand, their bodies telling a story that marine biologists couldn't quite decipher. The skulls were different, subtly but unmistakably. The proportions suggested a creature that had diverged from the killer whale family tree long ago, perhaps tens of thousands of years earlier. Yet genetic analysis wouldn't be available for decades, leaving these specimens as curious footnotes in dusty museum archives. What made these whales truly phantom-like wasn't just their rarity, but their behavior. Traditional killer whales are social, vocal, relatively easy to track once located. They breach, they hunt in coordinated pods, they announce their presence. Type D whales seem to follow different rules entirely. They glided through the water with an almost supernatural silence, appearing on sonar screens like shadows before dissolving back into the acoustic void of the deep ocean. The Southern Ocean itself became their greatest protection. These waters churn with some of the most violent weather systems on Earth, where 40-foot swells and hurricane-force winds make research expeditions a gamble with death. If you were a species that wanted to remain hidden from human observation, you couldn't choose a better stronghold. The Drake Passage, where many sightings occurred, earned its nickname as the graveyard of ships for good reason. Dr. Pittman's team began collecting DNA samples from the 1955 stranding, subjecting the decades-old tissue to modern genetic analysis. The results painted a picture that challenged everything scientists thought they knew about killer whale evolution. These weren't simply a regional variation or a subspecies that had adapted to Antarctic conditions. Their genetic signature suggested they had been isolated for so long that they might represent an entirely distinct species, one that had been living in the planet's most remote waters, largely unobserved by science. The implications rippled through marine biology. If a 30-foot predator could remain essentially unknown in the modern era of satellite tracking and global observation, what else might be lurking in the planet's least accessible waters? The Type D discovery forced researchers to confront an uncomfortable truth. Despite decades of ocean exploration, vast regions remained as mysterious as they had been to the first explorers who ventured into these icy realms. Local fishing communities had known about the strange whales for generations. Chilean fishermen called them blackfish of the deep, describing encounters with pods that moved with an almost ghostly coordination. These whales didn't hunt like their northern relatives, who might beach themselves to snatch seals or work together to create waves that wash prey from ice floes. Instead, they seemed to feed almost exclusively on fish, particularly the Patagonian toothfish that inhabited the same frigid depths. The 2019 encounter finally provided researchers with living specimens to study. The team managed to deploy satellite tags on several individuals, expecting to track their movements across the Southern Ocean. Instead, they discovered something even more puzzling. The whales disappeared into areas where the ocean floor dropped away into abyssal depths, regions where the cold, nutrient-rich waters created ecosystems that remained largely unexplored. Acoustic analysis revealed another mystery. Most killer whales have distinct vocal dialects, family languages passed down through generations. The Type D whales produced sounds that didn't match any known Orcinus orca vocalization patterns. Their calls were lower in frequency, almost haunting in their alien quality. Some researchers describe the recordings as more similar to the songs of deep-water species than to their surface-dwelling relatives. The satellite tracking data painted a picture of creatures adapted to one of Earth's most extreme environments. They dove deeper than expected, staying submerged for longer periods, moving through water temperatures that would quickly kill most marine mammals. Their behavior suggested a species that had not just survived but thrived in isolation, developing hunting strategies and social structures uniquely suited to the Antarctic wilderness. As climate change alters the Southern Ocean ecosystem, questions about the Type D whale's future become increasingly urgent. Their population numbers remain unknown. Estimates range from a few hundred to several thousand individuals. If they represent a distinct species that evolved in isolation, their genetic diversity might be extremely limited, making them vulnerable to environmental changes their ancestors never faced. The phantom whales continue to surface in research footage, their dark forms cutting through waters that remain largely unmapped and unexplored. Each sighting raises new questions about adaptation, evolution, and the hidden complexity of Earth's polar ecosystems. In an age when we assume every large animal on the planet has been cataloged and studied, these creatures remind us that the ocean still holds secrets worth protecting and mysteries worth pursuing into the endless cold of the world's most remote waters. The curious Katabatic winds, wind speeds that shouldn't exist in nature, have been recorded across Antarctica's vast ice sheets. On July 21, 1972, automatic weather stations at Cape Denison measured sustained winds of 200 miles per hour, speeds that rival Category 5 hurricanes, yet occurring in conditions no meteorologist had predicted. These weren't storm winds, they were Katabatic winds, and they've been rewriting our understanding of atmospheric physics for over a century. The word Katabatic comes from the Greek, meaning going downward, but that simple definition barely captures what these winds actually do. They begin as gentle air masses cooling over Antarctica's elevated ice plateaus. As the air grows denser, gravity should pull it downward toward the coast in predictable patterns, should being the operative phrase. Dr. Maria Kowalski spent 3 winters at McMurdo Station studying these phenomena. Her weather balloons, designed to track wind patterns up to 30,000 feet, kept disappearing, not drifting away, disappearing entirely. Radar would track them to a certain altitude, then nothing. The balloons weren't bursting, they were simply vanishing from all detection. The indigenous peoples of Tasmania have stories about winds that carry voices across impossible distances. Sailors in the Southern Ocean have reported hearing human conversations on clear nights. words spoken in languages they couldn't identify, carried on winds that seemed to come from nowhere. The Maori called them the breath of the sleeping giant. Modern science offers explanations for katabatic winds that sound reasonable on paper. Cold air accumulates over the ice sheet's interior, becomes denser than the surrounding atmosphere, and flows downhill under gravitational force. The Coriolis effect adds rotation. Topography channels the flow. Temperature differentials create acceleration zones. Clean, observable physics. Yet the numbers don't align. In 2019, a joint research team from the University of Colorado and the Australian Antarctic Division deployed a network of sensors across the Adelie coast. They wanted to create the most comprehensive map of katabatic wind behavior ever attempted. The results, published in an obscure atmospheric physics journal, raised more questions than they answered. The winds were demonstrating what researchers cautiously termed non-linear acceleration patterns. Translation: they were speeding up in ways that defied gravitational models. Air masses were gaining velocity as they moved across relatively flat terrain, with no additional gravitational or thermal input to explain the acceleration. More disturbing were the directional anomalies. Katabatic winds should flow from high elevation to low elevation, generally inland to coast, but sensors recorded winds flowing uphill for hours at a time, against gravity, against every known principle of atmospheric dynamics. These weren't measurement errors. Multiple independent instruments confirmed the same impossible readings. The temperature data presented another puzzle. Katabatic winds are born from cold air masses, typically measuring between -40 and -60 degrees Celsius. But some recorded winds carried air that was inexplicably warm, sometimes reaching temperatures 30 degrees higher than the surrounding atmosphere. The warm air contained no additional moisture that might explain heating through condensation. No volcanic or geothermal sources existed in the areas where these anomalies occurred. Local wildlife seemed aware of something researchers couldn't detect. Adelie penguins would flee their rookeries hours before katabatic wind events that no instruments had predicted. Leopard seals would disappear from coastal waters with similar timing. The animals weren't responding to barometric pressure changes or temperature drops. They were anticipating something else entirely. Dr. James Fletcher, an acoustic specialist from the Scott Polar Research Institute, joined the research team in 2021 to investigate reports of unusual sounds associated with the winds. His hydrophones, deployed both above and below the ice, recorded audio frequencies that shouldn't exist in atmospheric wind systems. The recordings revealed low-frequency harmonics, consistent patterns that resembled musical intervals more than random wind noise. Spectral analysis showed these weren't caused by air moving over irregular terrain or through ice formations. The harmonics were too precise, too mathematically consistent. They suggested the winds were interacting with something that was creating resonance, but with what? Indigenous accounts from sub-Antarctic islands describe winds that could speak to the ice. Whalers' logs from the 1800s mention winds that would start and stop with unnatural abruptness, as if controlled by an unseen hand. These historical references were dismissed as folklore until modern instruments began recording the same phenomena. The geological record holds additional mysteries. Ice core samples from areas with high katabatic wind activity show unusual isotope ratios, signatures that typically indicate the presence of materials not found in Earth's normal atmospheric composition. The isotopes appear in distinct layers corresponding to historical periods of increased wind activity. Recent satellite imagery has revealed another anomaly. Katabatic winds carve predictable patterns into snow and ice surfaces, but high-resolution photos from NASA's Operation Icebridge show geometric formations that don't match any known wind erosion patterns. The shapes are too regular, too precise, almost architectural in their consistency. The sound recordings continue to defy explanation. Dr. Fletcher's team isolated segments where the harmonic patterns create what acoustic physicists recognize as standing waves, stable, resonant frequencies that require specific geometric conditions to maintain. Standing waves need enclosed or semi-enclosed spaces to form. The open expanses of the Antarctic ice sheet provide no such environmental structure. Weather prediction models consistently fail when forecasting katabatic wind events. Computer simulations based on temperature, pressure, and topographical data produce results that bear little resemblance to actual wind behavior. The winds seem to operate according to principles that aren't included in meteorological equations. Perhaps most unsettling are the reports from research station personnel. Multiple witnesses describe Katabatic wind events preceded by a particular quality of silence. Not merely quiet, but an absence of sound so complete it feels unnatural. During these periods, radio communications fail, electronic instruments malfunction, and the Aurora Australis displays abnormal color patterns. The silence always ends the same way. A single note, clear and sustained, audible across miles of ice. Then the winds arrive with their impossible speeds and unexplainable temperatures, carrying sounds that shouldn't exist and following patterns that challenge our fundamental understanding of how air moves across the surface of our planet. The Katabatic winds of Antarctica continue to blow, carrying their secrets across landscapes where science meets the unknowable, where measured data reveals the limitations of our knowledge rather than expanding it. Alien fossils of Seymour Island. The fossil emerged from Seymour Island's frozen ground in 1982, and immediately, Dr. William Zinsmeister knew something was profoundly wrong. The specimen in his hands shouldn't exist. Not here, not now, not in any textbook he'd ever studied. This wasn't just another ancient remnant of Earth's distant past. The molecular structure, the cellular preservation, the very composition of what they'd uncovered, defied every model of terrestrial evolution. 3 decades later, teams of paleontologists, biochemists, and astrobiologists continue returning to this remote Antarctic outcrop, each expedition raising more questions than answers. Seymour Island sits like a time capsule at the edge of the world, where the Antarctic Peninsula reaches toward South America across the Drake Passage. Here, in this windswept landscape of exposed rock and perpetual ice, lies one of the most complete fossil records on Earth, and possibly beyond it. The island's geological layers span 65 million years, perfectly preserved in sedimentary rock that tells the story of Antarctica's transformation from tropical paradise to frozen wilderness. But within these layers, researchers have found specimens that simply don't belong to any known evolutionary timeline. In 1986, Dr. Zinsmeister's team discovered fossilized remains with cellular structures containing amino acid sequences that appear nowhere else in Earth's fossil record. The preservation was so complete that organic compounds remained intact, protected by the unique chemistry of Antarctic permafrost. When subjected to spectroscopic analysis, these compounds revealed isotope ratios that match no known terrestrial biology. The implications troubled the scientific community. Dr. Sarah Chen, a biochemist from the University of Colorado, spent 18 months analyzing tissue samples from Seymour Island specimens. Her findings, published in a heavily debated 1989 paper, suggested that some fossils contained protein chains with chirality patterns opposite to every known life form on Earth. On our planet, amino acids exist in a left-handed configuration, a fundamental characteristic of terrestrial biology. Yet these Antarctic specimens displayed predominantly right-handed amino acid structures, a mirror image of life as we understand it. The bacterial fossils presented even stranger anomalies. Conventional Earth bacteria possess cell walls made of peptidoglycan, a polymer found universally across terrestrial species. The Seymour Island specimens contained cell wall components that incorporated silicon-carbon bonds in ways that no known organism can produce. The energy requirements for such biological processes would exceed anything possible in Earth's current or historical atmospheric conditions. Dr. James Morrison, NASA's chief astrobiologist, first examined these specimens in 1994. His initial reaction was skepticism, followed by months of rigorous testing that only deepened the mystery. The fossilized organisms displayed metabolic pathways that would require atmospheric methane concentrations 400 times higher than anything Earth has experienced in the past billion years, yet the dating was unmistakable. Radiometric analysis placed these fossils at approximately 35 million years old, firmly within the Oligocene epoch when Antarctica was beginning its final transition to polar ice. The geological context was clear, the stratigraphic position undisputable, but the biology belonged to no known world. The preservation itself defied explanation. Unlike typical fossilization, where organic material is gradually replaced by minerals. These specimens retained original biological compounds in crystalline ice matrices that formed under conditions no Antarctic climate could produce. The ice structures required sustained temperatures of -180 degrees Celsius, combined with atmospheric pressure 3 times Earth's norm. In 2003, molecular biologist Dr. Elena Vasquez identified DNA fragments within several specimens that contained base pair sequences absent from any terrestrial genetic database. The sequences were complete enough to suggest functional genetic coding, yet they incorporated 6 nucleotide bases instead of the 4 that govern all known life on Earth. The statistical improbability of such findings occurring through natural evolutionary processes approaches mathematical impossibility. Dr. Richard Hayes from Cambridge calculated odds of 1 in 847 million against these molecular structures developing through random terrestrial evolution. More troubling discoveries emerged as excavation techniques improved. Ground-penetrating radar revealed extensive fossil beds extending deep beneath Seymour Island's surface, containing organic signatures unlike anything in Earth's paleontological record. Core samples from these depths yielded crystalline structures that appear to be fossilized technological components, geometric patterns too precise for natural formation. The island's isolation only increased the mystery's significance. Seymour Island has remained geologically stable for 40 million years, protected from tectonic activity that might introduce contamination from other regions. Whatever lived and died here belonged specifically to this place. During Earth's ancient climatic transition, government interest in Seymour Island intensified following the 2007 discoveries. 3 separate research teams were denied excavation permits without explanation, their applications disappearing into bureaucratic silence. Dr. Morrison's 2008 request for expanded sample analysis was rejected by NASA administrators who previously supported his work enthusiastically. The few specimens that reached international laboratories painted an increasingly alien picture. Electron microscopy revealed cellular organelles with internal structures that served no identifiable biological function, yet showed clear signs of sophisticated organization. These weren't random evolutionary experiments. They were engineered systems operating on principles we don't recognize. Recent climate data adds another layer to Seymour Island's enigma. Ice core analysis indicates that during the Oligocene, when these organisms lived, Antarctica experienced atmospheric conditions that closely match current models of early Mars. Methane levels, atmospheric pressure, and temperature ranges align with what astrobiologists theorize is necessary for the metabolic processes found in these fossils. The fossilized organisms seem perfectly adapted to an environment that Earth never supported, but another world might have. As Antarctic ice continues melting, more of Seymour Island's secrets emerge from their frozen preservation. Each new discovery strengthens the evidence for biological systems that originated beyond our planetary boundaries, yet the implications remain too vast for comfortable acceptance. The specimens wait in laboratory freezers around the world, their alien biochemistry challenging everything we thought we knew about life's possibilities. And somewhere beneath Seymour Island's permafrost, countless more secrets lie frozen in time, guards to mysteries that may rewrite our understanding of Earth's ancient visitors. The island keeps its silence, holding answers to questions we're only beginning to know how to ask. The Antarctic Blue Whale's Song. The recording lasted 17 minutes and 43 seconds. When marine biologist Dr. Elena Vasquez first played it back in her laboratory at McMurdo Station, the low-frequency pulses seemed to emerge from the depths of the Earth itself. She had captured something that defied every pattern in her extensive database of whale communications, a blue whale song that bore no resemblance to any documented call from these magnificent creatures. Blue whales produce the loudest sounds in the animal kingdom. Their calls can travel thousands of miles through ocean basins, carrying across entire continents of water. Yet the Antarctic populations sing differently than their cousins in warmer seas. Their songs descend to frequencies so low they exist at the very edge of human perception, reverberating through the frigid depths like acoustic ghosts. Dr. Vasquez had spent 8 years studying Antarctic blue whale vocalizations, but this recording challenged everything she understood about these creatures. The traditional blue whale song follows a predictable pattern. long, sustained notes that gradually decrease in frequency, like a cosmic sigh echoing through the abyss. But these Antarctic blues were doing something entirely different. The calls she recorded contained complex harmonic structures, layered frequencies that seemed to weave together in deliberate patterns. More unsettling still, the songs appeared to be synchronized across vast distances. Hydrophones separated by hundreds of miles were picking up coordinated vocalizations, not echoes or coincidences, but precisely timed communications that suggested a level of acoustic coordination never before documented in any marine species. When Dr. Vasquez shared her findings with colleagues around the world, the responses ranged from fascination to outright skepticism. Dr. James Moreau, a leading cetacean researcher at Woods Hole, spent weeks analyzing the recordings before admitting he had no framework for understanding what he was hearing. The mathematical precision of the harmonic intervals reminded him more of human music theory than animal communication. The mystery deepened when research teams began discovering that these unique vocalizations only occurred in Antarctic waters. Blue whales tracked migrating north would gradually shift their songs back to conventional patterns as they moved away from the polar regions. Something about Antarctica itself seemed to trigger this extraordinary behavioral change. Temperature couldn't explain it. Sound travels differently in cold water, but not in ways that would account for such dramatic changes in vocalization patterns. Ocean depth wasn't the answer either. Similar depth profiles in other regions produced no comparable effects. The unique acoustic properties of Antarctic waters remained frustratingly elusive. Dr. Sarah Chen, an acoustic oceanographer from the University of Tasmania, proposed that the songs might be responses to geological activity beneath the Antarctic ice sheet. The continent sits atop numerous active volcanic systems, and seismic activity could potentially influence marine life in unexpected ways. Her team deployed specialized equipment to monitor both whale songs and underground tremors simultaneously. The correlation they discovered was undeniable. The most complex whale vocalizations consistently occurred during periods of heightened seismic activity, but rather than random responses to geological noise, the whales seemed to be actively incorporating the Earth's rhythms into their communications. They were harmonizing with the planet itself. This finding raised profound questions about the sensory capabilities of these animals. Blue whales possess highly sophisticated hearing, but the idea that they could detect and respond to geological vibrations suggested perceptual abilities far beyond current scientific understanding. Were they somehow sensing tectonic movements through the ocean floor? Could they perceive magnetic field variations associated with Antarctic geology? The research took another unexpected turn when Dr. Vasquez noticed that the songs varied seasonally in ways that didn't correspond to known migration patterns or breeding cycles. The most complex vocalizations occurred during the Antarctic winter, when the continent experiences months of continuous darkness. During the brief summer season, the songs became simpler, more closely resembling traditional blue whale communications. Some researchers theorized that the extended darkness might enhance the whales' acoustic sensitivity, allowing them to perceive and respond to environmental cues that would be masked during brighter months. Others suggested that the winter ice formations might create unique acoustic environments that influence how sounds travel and resonate through the water. Dr. Chen's team made another disturbing discovery. The complexity of these Antarctic songs had been increasing over the past decade. Analysis of archived recordings revealed a clear progression toward more sophisticated harmonic structures and longer, more intricate compositions. The whales weren't just maintaining their unique communication system, they were actively developing it. This trend coincided with accelerating ice loss and geological instability across the Antarctic continent. As climate change reshaped the polar environment, the whales seemed to be responding with increasingly elaborate vocalizations. Whether this represented adaptation, distress, or something else entirely remained unclear. The research teams also documented instances where the whale songs seemed to influence other marine life. During periods of particularly complex vocalizations, researchers observed unusual aggregations of krill, squid, and fish. These gatherings occurred at depths where the whale songs would be most audible, suggesting some form of interspecies acoustic communication. Dr. Bott, Fernkopter, Hudkopter Wan, Dr. Bott, Moreau proposed that the Antarctic blue whales had developed a form of ecological echolocation, using their enhanced vocalizations to map not just physical terrain, but entire ecosystem relationships. Their songs might serve as acoustic censuses, gathering information about prey distributions, water temperatures, and even chemical gradients across vast ocean areas. The implications extend far beyond marine biology. If blue whales can detect and respond to geological activity with such precision, they might serve as early warning systems for significant environmental changes. Their songs could provide insights into Antarctic ice stability, volcanic activity, and ecosystem health that conventional monitoring systems miss entirely. Yet fundamental questions remain unanswered. We still don't understand the mechanisms by which these whales process geological information, or how they coordinate their vocalizations across such enormous distances. The mathematical precision of their harmonic structures suggests cognitive capabilities that challenge our assumptions about non-human intelligence. Recent recordings have captured something even more intriguing: moments when the whale songs seem to pause, as if waiting for responses from the Earth itself. During these silences, sensitive hydrophones detect subtle acoustic signatures from the seafloor, geological whispers that might represent the planet's half of an ongoing conversation. In the depths of Antarctic waters, blue whales continue their mysterious chorus, singing songs we cannot fully comprehend to an audience we are only beginning to recognize. Unseen Brilliance. Aurora Australis. At 3:47 a.m. Antarctic time on March 15, 2019, a physicist named Dr. Elena Marchetti witnessed something that made her question 40 years of atmospheric research. Standing outside Halley the 6th research station, she watched the southern aurora unfold above her in patterns that defied every model she'd helped develop. The lights didn't dance in the familiar curtains she'd studied for decades. Instead, they pulsed in perfect geometric spirals, rotating clockwise for exactly 17 minutes before reversing direction. Her magnetometer readings showed field fluctuations that shouldn't have been possible at that latitude. When she submitted her data to the International Aurora Research Consortium 6 months later, they asked her to recheck her instruments. She had, 3 times. The Aurora Australis has illuminated Antarctic skies for millennia, yet we've barely scratched the surface of its deeper mysteries. While tourists marvel at the dancing lights during brief summer expeditions, researchers stationed year-round in the polar night have documented phenomena that challenge our fundamental understanding of Earth's magnetic behavior. Consider the standard explanation we've accepted for generations: solar wind particles, charged and traveling at speeds reaching 2 million miles per hour, collide with our planet's magnetosphere. These particles follow magnetic field lines toward the poles, where they interact with atmospheric gases roughly 60 to 400 miles above Earth's surface. Oxygen produces green and red light, nitrogen creates blue and purple. Simple chemistry, predictable physics. Yet Antarctica's aurora refuses to follow these rules consistently. Dr. Marchetti's experience wasn't isolated. Throughout 2019 and 2020, multiple research stations across the Antarctic Peninsula reported similar anomalies. The McMurdo station logged 17 separate incidents of what they termed reverse aurora, lights that appeared to originate from ground level and ascend into the upper atmosphere. Traditional atmospheric physics suggests this should be impossible. Dr. James Holloway, a magnetospheric physicist who spent 8 consecutive Antarctic winters studying these phenomena, describes watching auroral displays that seem to respond to human-generated electromagnetic fields. "We were running diagnostic tests on our radio equipment," he explained in a 2021 interview. "Every time we powered up the transmitter, the aurora would shift position by roughly 15 degrees eastward, turn it off, and the lights would drift back to their original location." His team repeated this experiment 43 times over 6 weeks, documenting identical results each time. The correlation held statistical significance far beyond chance occurrence. Yet when they published their findings, the broader scientific community remained skeptical. The energy requirements for ground-based electromagnetic equipment to influence auroral activity should exceed anything possible with research station generators by several orders of magnitude. Antarctica's unique magnetic environment might hold answers to these contradictions. Unlike the Arctic, which sits atop oceans surrounded by continental land masses, Antarctica represents a massive continental plate covered in ice up to 3 miles thick. This configuration creates what researchers call a magnetic mirror effect. The continent's mineral composition and ice structure can influence how Earth's magnetic field lines behave in the southern polar region. But this explanation breaks down when we examine specific incidents recorded over the past decade. In 2018, researchers at Argentina's Belgrano second base photographed auroral formations that appeared to maintain perfect symmetry around a central point, roughly 200 miles inland from their location. The lights formed concentric circles, rather than the typical flowing curtains, rotating at measured intervals of exactly 4 minutes and 37 seconds per revolution. These circular formations persisted for 3 hours and 18 minutes before suddenly extinguishing. Satellite data from that evening shows normal solar wind activity and typical magnetic field strength across the region. Nothing in the recorded measurements explains why the aurora would organize itself into such precise geometric patterns. Similar reports have emerged from research stations across the continent. The German Neumayer station documented what their team described as structured light phenomena on 14 separate occasions between 2017 and 2022. These events featured aurora that appeared to form letters or symbols against the polar sky, maintaining recognizable shapes for periods lasting 15 to 45 minutes. Dr. Sarah Chen, an atmospheric physicist who analyzed the Neumayer station data, found herself facing an uncomfortable reality. The probability of random particle interactions creating recognizable symbolic patterns is mathematically negligible, she noted in her preliminary report. Yet we have high-resolution imagery of these formations from multiple independent observation points. The implications extend beyond mere curiosity. If auroral activity in Antarctica behaves differently than current models predict, our understanding of Earth's magnetic protection system might require fundamental revision. The magnetosphere shields our planet from potentially harmful solar radiation. Any gaps in our knowledge could affect everything from satellite operations to long-term human space exploration planning. Indigenous peoples of the Arctic have long held that aurora represents communication from spiritual realms. While scientific minds typically dismiss such perspectives as folklore, some researchers now wonder if traditional knowledge might contain observational insights Western science has overlooked. Antarctica, unlike the Arctic, has no indigenous population with centuries of oral observation experience. We're studying these phenomena without the benefit of generational knowledge. Recent advances in ground-penetrating radar have revealed another complicating factor. The ice beneath Antarctica contains extensive cave systems and underground water networks previously unknown to science. These subterranean features could interact with electromagnetic fields in ways we don't yet understand, potentially influencing how auroral particles behave when they reach the continent's magnetic environment. Dr. Marchetti continues her research, now leading an international team focused specifically on Antarctic auroral anomalies. Their preliminary findings suggest that the continent's aurora might operate according to principles that extend beyond conventional magnetospheric physics. They've documented over 200 separate incidents of unusual auroral behavior since 2019, building a database that challenges existing theoretical frameworks. Standing beneath the Antarctic sky during polar night, watching lights dance in patterns that shouldn't exist according to our current understanding, researchers find themselves confronting a humbling truth. The Aurora Australis, beautiful and mysterious as it appears to casual observers, might represent something far more complex than we've imagined. Each unusual display raises new questions about the fundamental forces shaping our planet's interaction with the cosmos above. The lights continue their eternal dance above the frozen continent, keeping secrets we're only beginning to recognize. Frozen Pompeii, the fossils of Beardmore Glacier. When paleontologists first encountered the fossil beds of Beardmore Glacier in 1908, they discovered something that defied every assumption about preservation. These weren't just ancient remains scattered across rock formations. They were finding complete ecosystems, frozen in time with such precision that leaves still held their cellular structure after 250 million years of entombment. The comparison to Pompeii isn't merely poetic. Just as volcanic ash instantly preserved that Roman city, The Beardmore Glacier has created what scientists now recognize as one of Earth's most extraordinary natural museums. But unlike Pompeii's tragic single moment, this frozen archive spans geological epochs, each layer revealing secrets about worlds that existed long before humans walked the planet. Dr. Patricia Ryberg made headlines in 2017 when her team extracted what appeared to be ordinary rock from the glacier's moraine. Under microscopic examination, that rock revealed something extraordinary: perfectly preserved stomata, the tiny pores that ancient plants used for gas exchange. These microscopic structures, smaller than the width of a human hair, had survived intact for 250 million years. The preservation here challenges fundamental assumptions about fossil formation. Traditional fossilization requires specific chemical conditions, usually involving mineral replacement over millions of years. What's happening at Beardmore operates by entirely different rules. The extreme cold and unique mineral composition of the ice have created a preservation environment so effective that scientists can still identify the original organic compounds in these ancient specimens. Among the most remarkable discoveries are the Glossopteris forests. These seed ferns once dominated the supercontinent Gondwana, and their fossils tell a story that reshapes our understanding of ancient Antarctica. The specimens show clear evidence of seasonal growth patterns, rings that indicate these plants experienced regular cycles of warmth and cold. This was no tropical paradise, but rather a temperate ecosystem that somehow thrived at the bottom of the world. The detail preserved in these fossils borders on the miraculous. Researchers have found leaves with their venation patterns intact, root systems still connected to parent plants, and even fossilized soil horizons that preserve the chemistry of ancient Earth. Dr. Eric Gulbranson's team discovered wood samples so well preserved that they could identify individual tree species and determine that some ancient Antarctic trees lived for over 400 years. But the Beardmore fossils raise as many questions as they answer. How did these temperate forests survive Antarctic winters that would have lasted months in complete darkness? The plants show clear adaptations to extreme light conditions, with unusually thick annual rings suggesting rapid growth during brief summer seasons. Yet the energy requirements for such growth cycles seem impossible, given the available sunlight at these latitudes. The geological context adds another layer of mystery. These fossils come from the Buckley Formation, sedimentary rocks laid down during the Permian period when Antarctica occupied roughly the same position it does today. Continental drift cannot explain away the climate puzzle these specimens present. Something about Earth's ancient atmosphere, ocean currents, or perhaps the planet's axial tilt was radically different from current models predict. Recent discoveries have pushed the boundaries of preservation even further. In 2019, researchers found what appeared to be fossilized fungal networks, mycorrhizal relationships between plants and fungi preserved in stunning three-dimensional detail. These symbiotic connections, essential for plant survival in harsh conditions, offer clues about how life adapted to Antarctica's challenging ancient climate. The diversity of life forms emerging from the Beardmore ice challenges every assumption about polar ecosystems. Alongside the dominant Glossopteris forests, researchers have identified over 30 plant species, evidence of complex food webs, and indications of seasonal animal migrations. This wasn't a barren landscape struggling to support minimal life, but rather a thriving ecosystem comparable to modern temperate forests. What makes these discoveries particularly unsettling is their implications for current climate models. If Antarctica supported such rich ecosystems in the past, what does that suggest about the continent's potential future? The fossil evidence indicates that Earth's polar regions have experienced dramatic climate swings throughout geological history, swings that current warming trends might trigger again. The technical challenges of extracting and studying these fossils add to their mystique. Working at Beardmore requires researchers to operate in temperatures that can drop below -50 degrees Fahrenheit, where metal tools shatter and exposed skin freezes in minutes. The fossils themselves are often embedded in ice-cemented rock that requires specialized equipment to extract safely. Dr. Benjamin Baumfleur's analysis of fossilized pollen presents perhaps the most intriguing evidence. His team identified pollen grains so well preserved that they could determine the exact flowering seasons of plants that bloomed 250 million years ago. The pollen assemblages suggest coordinated reproductive cycles across different species, indicating a level of ecosystem sophistication that rivals modern temperate forests. The preservation extends beyond plants into the realm of ancient atmospheres. Researchers have found evidence of ancient air bubbles trapped within the fossilized wood, potentially preserving samples of Permian atmosphere. Initial analysis suggests atmospheric compositions significantly different from current models, with implications for understanding ancient climate systems and the evolution of Earth's atmospheric chemistry. Yet despite decades of research, fundamental questions remain unanswered. The mechanism responsible for such extraordinary preservation continues to elude complete understanding. The chemical analysis reveals that organic compounds, thousands of times older than any previously discovered, remain chemically active, defying conventional wisdom about molecular decay. As climate change accelerates the retreat of Antarctic ice, these ancient time capsules are becoming increasingly accessible to researchers. Each melting season exposes new fossil beds, new species, and new questions about our planet's deep history. The Beardmore Glacier continues to release its secrets slowly, each discovery adding another piece to a puzzle that spans geological time. The frozen museum of Beardmore Glacier stands as testament to Earth's capacity for preservation and surprise. In this remote corner of Antarctica, ancient worlds wait patiently in their icy tombs, ready to challenge our understanding of life, climate, and the deep connections between past and future that shape our planet's story. Vostok Station's icy chronicles. The thermometer read -89.2 degrees Celsius when Soviet researchers at Vostok Station recorded what remains the coldest temperature ever measured on Earth's surface. But that bone-crushing cold wasn't the strangest thing happening at this remote outpost in the heart of Antarctica. 3 miles beneath their feet lay something that would rewrite our understanding of Earth's ancient climate and possibly life itself. Vostok Station sits at the center of nowhere. No trees, no animals, no sound except the howling wind across endless ice. The nearest human settlement lies over 1,000 miles away. Yet this desolate research station has become one of the most important scientific sites on our planet, not for what exists on the surface, but for what lies hidden in the frozen layers below. The Russians established Vostok in 1957 during the International Geophysical Year. They chose this location not for its hospitality. The station holds records for both the coldest temperature and some of the most brutal living conditions on Earth, but for what the ice could tell them. At Vostok, the Antarctic ice sheet reaches its greatest thickness, nearly 3 miles of compressed snow and ice accumulated over hundreds of thousands of years. Each layer represents a moment in Earth's climate history, trapped and preserved like pages in a massive frozen library. But extracting these pages requires a precision that borders on the impossible. Too much heat from the drilling equipment melts the samples, too little, and the drill bits shatter in the crushing cold. The men and women working at Vostok developed techniques that seem almost miraculous, pulling pristine ice cores from depths where the pressure could crush a human body in seconds. Dr. Vladimir Kotlyakov, one of the station's longtime researchers, described the deeper cores as messages from a world we never knew existed. The ice from 2 miles down formed when our planet looked nothing like it does today. Atmospheric compositions that would be toxic to modern life. Temperature swings that make our current climate change debates seem almost quaint by comparison. But the real mystery began when the drill bits hit something unexpected at 12,366 feet below the surface. Water. Liquid water. In a place where everything should be frozen solid for miles, this wasn't just any water. It was Lake Vostok, a body of water the size of Lake Ontario, hidden beneath the ice for potentially millions of years. The implications started small, but grew exponentially. If water existed in liquid form at these depths, it suggested heat sources that conventional geology couldn't fully explain. Geothermal activity, certainly, but the measurements didn't quite add up. The water remained liquid at temperatures and pressures where it should have crystallized into exotic forms of ice that exist nowhere else on Earth's surface. More puzzling still were the electromagnetic readings coming from the lake itself. Soviet equipment detected magnetic anomalies beneath the water, suggesting metallic objects or mineral formations that defied standard geological models. When word of these readings leaked to the international scientific community in the 1990s, research teams from 12 nations requested access to the site. The drilling continued for decades, but each breakthrough raised more questions than it answered. Ice cores from just above the lake contained mineral particles that shouldn't exist at this location, chemical signatures that suggested biological activity. Most unsettling of all, microscopic formations that bore an uncanny resemblance to fossilized microorganisms, preserved in ice that formed when complex life on Earth's surface was still millions of years away from evolving. Dr. Alexei Yemelyanov, who spent 4 winters at Vostok studying these deep ice samples, noted something that still troubles the scientific community. The deepest cores, those taken from directly above Lake Vostok, contained air bubbles with atmospheric compositions that didn't match any known period in Earth's climate record. Oxygen levels that would have made the planet uninhabitable. Carbon dioxide concentrations that suggested volcanic activity on a scale never documented in the geological record. Yet there they were, trapped in ice that showed no signs of contamination or drilling artifacts. The station's isolation began working against the research teams in unexpected ways. Equipment failures in the brutal cold meant that many experiments could only be attempted once. Supply runs occurred just once per year, during the brief Antarctic summer, so any missing components or failed instruments meant waiting 12 months for replacement parts. This enforced patience created an unusual scientific environment, where researchers had months to study each sample, developing theories that grew more complex and speculative during the long polar nights. Some of the most intriguing discoveries never made it into official publications. Research journals from Vostok describe ice formations that seem to show directional flow patterns, as if the frozen layers had been disturbed by movement from below. Computer models couldn't replicate these patterns using known geological processes. The shapes suggested something had been moving through the lake system, displacing water in ways that eventually affected the ice formation above. Temperature readings from the deepest drilling points revealed another anomaly. The water in Lake Vostok maintained a consistent temperature that was several degrees warmer than geothermal models predicted. The heat source remained unidentified. Some researchers theorized about radioactive materials concentrated in the lake bed. Others proposed unknown forms of bacterial life generating heat through exotic metabolic processes. But the most unsettling discovery remained classified for years. Deep drilling samples contained crystalline formations that bore no resemblance to any natural ice structures. These formations appeared to be artificial, too geometric, too precisely arranged to have formed through natural processes. They suggested that something in Lake Vostok was organizing the freezing process, creating patterns that shouldn't exist in nature. When international research teams finally gained access to Vostok's deepest samples in the early 2000s, their analysis confirmed the Soviet findings but added new mysteries. DNA traces in the ancient ice didn't match any known species. They weren't even close enough to Earth life forms to suggest evolutionary relationships. These microscopic genetic signatures looked more like contamination from another planet than evolution on our own. The researchers at Vostok continue their work today, pulling ice cores from depths that represent millions of years of Earth's hidden history. Each sample reveals a planet that was stranger and more volatile than we ever imagined. But the deeper they drill, the more they realize that Antarctica's ice doesn't just preserve the past. It guards secrets that challenge everything we thought we knew about life, climate, and possibly our place in the cosmos. The coldest place on Earth keeps giving up its warmest mysteries. The shapes of Lake Untersee. In 2008, when German researchers first lowered their cameras through the ice of Lake Untersee, they expected darkness and perhaps some bacterial mats. What they found instead were towering spires of living stone, reaching upward through the frigid water like ancient cathedrals frozen in time. These weren't rocks, they weren't coral formations, they were microbialites, massive structures built entirely by microorganisms over thousands of years, each one a monument to life's stubborn persistence in conditions that should, by all reasonable expectations, remain sterile. Dr. Dale Anderson had spent decades studying extreme environments, but even he paused when the first images transmitted back from Lake Untersee's depths. The structures rose nearly 20 feet from the lake floor. their surfaces rippling with layers that spoke of countless generations of microscopic architects. In the perpetual darkness beneath Antarctica's ice, something had been quietly building cities. Lake Untersee sits in the Gruber Mountains of East Antarctica, sealed beneath ice that hasn't melted for millennia. The lake itself spans roughly 2.5 square miles, but its true significance lies not in size but in chemistry. The water maintains a pH level of 10.4, more alkaline than household bleach, and remains liquid year-round despite surface temperatures that would freeze human breath in seconds. This chemical cocktail should be toxic to most life forms. Instead, it's become a nursery. The microbialites of Untersee represent something unprecedented in polar research. Unlike their cousins in warmer climates, these structures show no seasonal variation, no response to changing light cycles or temperature fluctuations. They exist in a state of geological patience, growing imperceptibly in conditions that mirror what astrobiologists believe they might find beneath the ice of Jupiter's moon Europa or Saturn's Enceladus. When researchers first analyzed samples from these living towers, they discovered communities of cyanobacteria and other microorganisms that had evolved in complete isolation from the rest of Earth's biosphere. These weren't merely survivors, they were specialists, perfectly adapted to their alien environment. Some species showed metabolic pathways that researchers had only theorized about in laboratory settings. The formation process itself defies conventional understanding. In most environments, microbialites grow through photosynthesis, with cyanobacteria using sunlight to precipitate calcium carbonate. But Lake Untersee exists in perpetual darkness. The organisms here have found another way, possibly drawing energy from chemical reactions with the lake's mineral-rich waters, or from radioactive decay in the surrounding bedrock. Dr. Anderson's team discovered that the lake's extreme alkalinity comes from a combination of factors unique to this location. Meltwater from the surrounding ice interacts with specific rock formations, creating what's essentially a naturally occurring chemistry experiment that's been running for thousands of years. The result is an environment so unlike anything else on Earth that NASA has designated it an official analog site for extraterrestrial research. But the mysteries of Lake Untersee extend beyond its living structures. Beneath the microbialite towers, researchers have detected what appears to be a secondary ecosystem, layers of sediment that suggest the lake's chemistry has fluctuated dramatically over geological time. Core samples reveal periods when the water was less alkaline, possibly supporting entirely different forms of life that have since vanished or evolved beyond recognition. Temperature readings from the lake floor show unexpected warm spots that can't be fully explained by geothermal activity alone. Some researchers theorize that the microbialites themselves might be generating heat through their metabolic processes, creating microenvironments within the larger ecosystem. Others suggest that unknown chemical reactions in the lake's depths are producing energy in ways that conventional biology textbooks don't account for. The implications ripple outward from this frozen laboratory in ways that keep astrobiologists awake at night. If life has not only survived but thrived in Lake Untersee's extreme conditions, what does that suggest about the potential for life in the subsurface oceans of icy moons throughout our solar system? The chemical signatures that Anderson's team has documented match several key parameters that planetary scientists have identified as potentially life-supporting in extraterrestrial environments. European Space Agency researchers have begun using Lake Untersee as a testing ground for instruments designed for future missions to Europa and Enceladus. The challenges of operating in the lake's harsh environment, the difficulty of drilling through the ice, the problems of maintaining equipment in highly alkaline water, the complexities of collecting uncontaminated samples mirror many of the obstacles that robotic missions will face when searching for life beyond Earth. Yet perhaps the most intriguing aspect of Lake Untersee lies in what researchers haven't found. Genetic analysis of the microbialite communities reveals gaps in the evolutionary tree that suggest either unknown extinction events or the presence of organisms so different from known life forms that current classification systems can't accommodate them. Some DNA sequences recovered from the deepest parts of the lake don't match anything in existing databases. The lake isolation has created what evolutionary biologists call a natural laboratory for studying how life adapts to extreme conditions over extended periods. Unlike laboratory experiments that run for months or years, The organisms in Lake Untersee have had millennia to develop their unique survival strategies. They represent evolution's long-term solutions to problems that life might encounter throughout the universe. Recent expeditions have revealed that the microbial structures show evidence of internal organization that wasn't immediately apparent in early surveys. Cross-sections reveal chambers and channels that seem to facilitate the flow of nutrients and waste products throughout the living towers. Whether this organization is purely the result of physical and chemical processes, or represents some form of primitive cognition, remains an open question that challenges our understanding of where the line between life and intelligence truly lies. As research continues, Lake Untersee keeps revealing new layers of complexity. Each answer leads to deeper questions about the nature of life itself, the boundaries of habitability, and the possibility that in the frozen depths of Antarctica, we're glimpsing what alien life might look like when we finally find it among the stars. Antarctic anomalies, ghost mountains, radar waves penetrating 2 miles beneath East Antarctica's ice sheet revealed something that shouldn't exist: a mountain range the size of the European Alps, completely buried and invisible to every explorer who ever crossed that frozen expanse above. The Gamburtsev Mountains stretch across 750 miles of subglacial terrain, their peaks reaching heights that would rival Colorado's Rockies if anyone could see them. For over 4 billion years, these phantom mountains maintained their jagged profiles beneath an ice tomb that began forming 34 million years ago. When Russian scientists first detected their radar signatures in the 1950s, the discovery was met with geological bewilderment. Mountains should erode. Mountains should weather down to gentle hills over millions of years, especially mountains trapped beneath grinding ice sheets that exert pressures exceeding 200 tons per square foot. The Gamburtsevs refused to follow these rules. Dr. Rees, Darren, Fausto Ferraccioli led the most comprehensive survey of these ghost mountains in 2008, using ice-penetrating radar and gravity measurements to map their hidden contours. What his team discovered challenged fundamental assumptions about how mountain ranges form and survive. Sharp ridges and deep valleys carved patterns beneath the ice that resembled landscapes carved yesterday, not geological features that predated the dinosaurs. Continental collisions typically birth mountain ranges. When tectonic plates crash together, rock layers buckle upward, creating the dramatic peaks we associate with ranges like the Himalayas or the Andes. But East Antarctica sits in the middle of an ancient craton, a stable piece of continental crust that hasn't experienced major tectonic activity for over 500 million years. No plate boundaries exist nearby. No recent geological violence occurred here that could explain these towering peaks. The radar data revealed something even stranger. These mountains appear to be the birthplace of the East Antarctic ice sheet itself. Computer models suggest that as global temperatures dropped 34 million years ago, snow first began accumulating on these high peaks, gradually spreading outward to form the massive ice cap that now covers 14 million square kilometers. The very mountains that should have been destroyed by this ice sheet were actually responsible for creating it. Robin Bell, a geophysicist who spent years studying the Gamburtsev data, described them as a city buried under ice, but instead of buildings, you have mountains. Her team's measurements showed valleys deeper than the Grand Canyon, carved into bedrock that lies far below sea level. Some of these valleys contain liquid water, flowing in river systems that have remained hidden beneath the ice for millions of years. The preservation of these sharp mountain features suggests something unprecedented in geological terms. While surface mountains around the world gradually wear down through wind, rain, and temperature cycling, the Gamburtsevs have remained frozen in time. The constant sub-zero temperatures and protective ice cover created conditions unlike anywhere else on Earth. These mountains exist in a state of suspended geological animation. Analysis of ice cores drilled near the range revealed another mystery. Trapped air bubbles and sediment layers told a story of climate stability that shouldn't exist. The ice above these mountains has remained continuously frozen through climate periods that melted glaciers across the rest of the planet. During warm interglacial periods that raised global sea levels by hundreds of feet, the ice above the Gamburtsevs never budged. Some researchers propose that the mountain's elevation creates its own microclimate, trapping cold air in a perpetual deep freeze that insulates them from global warming trends. Others suggest that the bedrock composition might contain unusual minerals that affect local temperature regulation. But these theories remain speculative, unable to fully explain why this particular patch of Antarctica behaves so differently from everywhere else. The presence of liquid water beneath the ice adds another layer to the mystery. Seismic surveys detected what appear to be active river systems flowing through valleys carved between the mountain peaks. These subglacial waterways maintain temperatures just above freezing, sustained by geothermal heat rising from the Earth's core. The combination of ancient mountains, stable ice coverage, and hidden water systems creates an environment that may have remained unchanged for geological ages. Biological samples extracted from ice cores above the Gomburtsevs contain microorganisms unlike those found anywhere else in Antarctica. These extremophiles appear adapted to conditions of prolonged isolation and minimal nutrients, suggesting they may have evolved separately from life forms in the outside world for millions of years. If liquid water systems exist beneath the ice, they could harbor ecosystems that developed in complete isolation since the ice sheet formed. The most intriguing possibility involves what lies beneath the bedrock itself. Gravity measurements indicate density variations in the deep crust beneath the mountains that don't match typical rock formations. Some geologists speculate about the presence of mineral deposits or geological structures that could explain both the mountains' unusual preservation and their resistance to normal erosion processes. Recent satellite data revealed that the ice surface above the Gomburtsevs shows subtle undulations that mirror the mountain topography 2 miles below. This suggests ongoing interaction between the bedrock and the ice sheet, with the mountains continuing to influence ice flow patterns despite their burial. The ice moves differently here, creating currents and pressure zones that may contribute to the range's preservation. Attempts to drill down to the actual mountain rock have failed due to the extreme depths required and the technical challenges of maintaining equipment in such conditions. The deepest ice cores have reached within half a mile of the bedrock, but the mountains themselves remain physically untouched by human exploration. They exist as phantom peaks known only through remote sensing and geological inference. The Gomburtsev Mountains represent more than a geographical curiosity. They challenge our understanding of how landscapes evolve over deep time. Their existence suggests that under the right conditions, geological features can remain virtually unchanged for periods that span multiple mass extinctions and continental rearrangements. These ghost mountains have witnessed the rise and fall of dinosaurs, the breakup of ancient supercontinents, and countless climate cycles, all while maintaining their sharp-edged profiles in frozen darkness. Perhaps most remarkably, these mountains may hold keys to understanding how ice ages begin and end, and how climate systems operated during periods of Earth's history that remain poorly understood. They stand as silent sentinels beneath the ice, guardians of secrets that have yet to be fully revealed. Antarctica's time capsule. Fossilized forests. Deep beneath Antarctica's frozen shell, paleontologists uncovered something that rewrites our understanding of Earth's past. Perfect fossils of towering trees, their cellular structure preserved in impossible detail, from a time when this land of ice was a thriving rainforest. These aren't fragments or impressions. We're talking about complete tree trunks, some over 40 feet tall, with bark patterns still visible under microscopic examination. The preservation is so extraordinary that scientists can identify individual growth rings, study the cellular walls, and reconstruct entire ecosystems that vanished 280 million years ago. Dr. Eric Gulbrandsen was part of the team that made these discoveries in the Transantarctic Mountains. In his field notes, he described the moment they realized what they'd found. "We were looking at a forest floor, complete with fallen logs, root systems still in position, and layers of leaves that had accumulated season after season. It was as if someone had flash frozen an entire woodland ecosystem. The science behind this preservation defies easy explanation. Fossilization typically requires specific conditions: rapid burial, mineral replacement, protection from oxygen. But these Antarctic specimens show a level of preservation that suggests something more immediate, more catastrophic than the gradual processes we understand. In the Freemu Formation, researchers have recovered not just tree fossils, but entire forest communities. Glossopteris trees, some with trunks 3 feet in diameter, stand exactly where they grew nearly 300 million years ago. Their root systems extend deep into what was once fertile soil, now turned to stone. Seed ferns spread their fronds between the larger trees, and primitive conifers filled the understory. What makes these discoveries particularly unsettling is their placement within geological time. These forests existed during the Permian period, when Antarctica was positioned differently on Earth's surface, part of the supercontinent Gondwana. The trees grew in a climate that supported lush vegetation, with seasonal variations that allowed for the complex ecosystems we see preserved in stone. The Glossopteris fossils present their own mystery. This genus of seed fern was found across the southern continents: Antarctica, Australia, South Africa, South America, and India. The identical nature of these fossils across vast oceanic distances provided early evidence for continental drift, but recent analysis suggests something more complex. Dr. Molly Miller, examining these specimens at Vanderbilt University, noticed patterns that conventional wisdom couldn't explain. The Glossopteris leaves show evidence of insect damage, fungal infections, and seasonal stress markers that indicate a sophisticated ecosystem. More puzzling, some specimens show signs of rapid environmental change, growth patterns that suggest the climate shifted dramatically within single growing seasons. The preservation process itself challenges our understanding of fossilization. In traditional scenarios, organic material decomposes while minerals gradually replace the cellular structure. These Antarctic forests show evidence of instantaneous preservation: organic compounds still present, cellular details intact, even microscopic fungi preserved within the wood grain. When researchers cut thin sections of these fossilized trees for microscopic analysis, they discovered something remarkable. The cellular structure wasn't just preserved, it was perfect. Stomata, the tiny pores leaves use for gas exchange, remained clearly visible. Resin ducts in the wood showed their original configuration. Even pollen grains were found intact within the reproductive structures. This level of preservation typically requires extraordinary circumstances. The Pompeii analogy comes to mind, a catastrophic event that instantly entombed living organisms. But unlike Pompeii's volcanic ash, Antarctica's fossilized forests show no evidence of violent destruction. The trees appear to have been growing normally when the preservation process began. Radiocarbon dating places these forests at the boundary between the Permian and Triassic periods, coinciding with the largest mass extinction in Earth's history. The Permian-Triassic extinction eliminated roughly 90% of marine species and 70% of terrestrial vertebrates. These Antarctic forests may represent the final chapter of Earth's largest ecological collapse. Recent expeditions have uncovered evidence that these forests didn't die gradually. Growth ring analysis shows that many trees were actively growing when the preservation process began. Leaf litter beneath the trees contained specimens from different seasons, suggesting normal forest cycles continued until the moment everything stopped. The geographic distribution of these fossil sites raises additional questions. They're found at specific elevations within the Transantarctic Mountains, always at similar altitudes, as if a precise environmental threshold determined where preservation occurred. Below certain elevations, fossils deteriorate rapidly. Above others, preservation becomes so complete, it borders on the impossible. Temperature analysis of the fossilized wood suggests these trees grew in conditions far warmer than Antarctica has experienced in recorded geological history. The cellular structure indicates average temperatures between 60 and 70 degrees Fahrenheit, with seasonal variations supporting complex ecosystems. This presents a paradox. How did such temperate forests exist at what would have been high southern latitudes, even accounting for continental drift? Dr. Patricia Ryberg's team at the University of Kansas made another discovery that deepens the mystery. Within the fossilized wood, they found preserved DNA fragments. The genetic material was degraded but recognizable, providing direct molecular evidence of these ancient organisms. Some sequences matched no known plant families, suggesting entire evolutionary lineages that vanished without descendants. The pollen record from these sites tells a story of rapid ecological change. Lower sediment layers show diverse pollen assemblages, indicating rich, complex ecosystems. Higher layers reveal dramatic shifts in species composition, followed by an abrupt end to pollen deposition. The transition appears to have occurred over geological moments, not the millions of years typically associated with major environmental changes. Perhaps most intriguingly, some fossil sites show evidence of human-like activity. Cut marks on fallen logs, deliberate arrangement of branches, clearings that suggest intentional forest management. These markings predate accepted timelines for complex life by hundreds of millions of years, creating uncomfortable questions about Earth's biological history. The Antarctic fossil forests force us to reconsider fundamental assumptions about our planet's past. They preserve evidence of ecosystems that thrived under conditions we can barely reconstruct, using preservation mechanisms we don't fully understand, during time periods that challenge our models of evolutionary development. Each specimen recovered from the ice raises new questions about the forces that shaped our world. These ancient trees stand as silent witnesses to chapters of Earth's story we're only beginning to comprehend. The secret of Deception Island's hot springs. Steam rises from waters that shouldn't exist, defying the fundamental logic of Antarctica's frozen dominion. On Deception Island, natural hot springs bubble and churn at temperatures reaching 70 degrees Celsius, creating an impossible oasis where penguins wade through heated pools while glacial winds howl overhead. The contrast isn't just remarkable, it's scientifically perplexing. Deception Island sits like a broken ring in the South Shetland archipelago, its horseshoe shape betraying the violent forces that created it. What appears to be a sheltered harbor is actually the flooded caldera of an active volcano, one that maintains geothermal activity so intense it melts snow on contact. Visitors describe the surreal experience of watching steam clouds rise from black volcanic beaches while icebergs drift past in the distance. The island's deceptive nature extends far beyond its name. British naval charts from the early 1800s marked it as solid land, only for later expeditions to discover the narrow channel that opens into the protected waters of Port Foster. This hidden entrance earned the island its moniker, but the real deception lies in what happens beneath its waters. Marine biologist Dr. Elena Vasquez spent 3 months studying the thermal zones in 2019. Her measurements revealed something that challenged conventional understanding of polar ecosystems. The hot springs don't simply exist, they thrive with life forms that shouldn't survive in Antarctic conditions. Microscopic organisms flourish in water temperatures that would kill most polar-adapted species, while maintaining metabolic processes that require environmental conditions found thousands of miles north. The geothermal activity follows patterns that geological models struggle to explain. Temperature readings vary dramatically across distances measured in mere meters. One thermal vent produces water hot enough to cause second-degree burns, while springs less than 50 feet away maintain temperatures barely above freezing. The volcanic system appears to operate on principles that don't align with standard geothermal behavior. Local wildlife exhibits adaptations that evolutionary biology can't easily account for. Chinstrap penguins gather around the heated areas during the harshest weather, displaying behavioral patterns documented nowhere else in their range. They've learned to use the thermal zones for thermoregulation in ways that suggest generational knowledge, but the island's volcanic history includes eruptions violent enough to sterilize all life. The most recent major eruption occurred in 1970, covering research stations with volcanic ash and forcing complete evacuation. When scientists returned, they expected to find a devastated ecosystem. Instead, life had not only survived, but appeared to have adapted to the changed conditions with impossible speed. Species that should have required decades to re-establish themselves were thriving within months. Seismic monitoring equipment records unusual activity patterns beneath the island. The volcanic system shows signs of chambers and magma flows that don't match the visible topography. Ground-penetrating radar suggests the presence of extensive cave networks filled with superheated water, creating a hidden thermal ecosystem larger than the surface features would indicate. Chemical analysis of the hot spring water reveals mineral compositions that raise questions about their source. Trace elements present in the thermal springs match geological signatures found in continental Antarctica, hundreds of miles away across the Drake Passage. The mineral transport mechanisms required to create these compositions remain unexplained. Temperature gradient mapping shows the geothermal influence extends underwater in patterns that contradict oceanographic models. Thermal cameras reveal heated water columns rising from the seafloor in precise geometric arrangements. The spacing and intensity suggest underlying structures that organized survey has yet to identify. Research teams have documented instances where the hot springs appear to respond to tidal cycles in ways that geothermal systems shouldn't. Water temperatures fluctuate with lunar phases, rising and falling according to patterns that imply connections to deep-sea thermal networks. The correlation is subtle, but consistent across multiple measurement periods. Ice core samples taken from glacial areas on the island contain atmospheric particles that date to periods when the volcano showed no surface activity. The preservation of these materials suggests periods of geothermal stability lasting thousands of years, interrupted by events that left no other geological evidence. The thermal history preserved in the ice doesn't match the violent volcanic timeline that surface features suggest. Microbiological studies have identified bacterial communities in the hot springs that share genetic markers with organisms found in deep ocean thermal vents near the mid-Atlantic ridge. The genetic similarities can't be explained by known dispersion mechanisms. These organisms appear to have developed independently while maintaining identical adaptive strategies. The island's magnetic field shows localized anomalies that interfere with navigation equipment. Compass readings shift unpredictably near certain thermal features, and GPS devices experience accuracy problems that correlate with geothermal activity levels. The magnetic disturbances follow patterns that suggest the presence of highly magnetized materials at specific depths. Weather patterns around Deception Island create microclimates that meteorological models can't predict accurately. The interaction between geothermal heat and polar air masses produces atmospheric effects documented nowhere else in Antarctica. Localized temperature inversions create pockets of warm air that persist despite wind conditions that should disperse them immediately. Archaeological evidence from abandoned whaling stations indicates that early visitors recognized unusual properties in the island's thermal features. Personal journals from 1920s whale oil processing operations describe workers using the hot springs for purposes that official records don't detail. References to healing waters and unusual effects appear repeatedly but without specific explanation. Modern satellite thermal imaging reveals that the island's heat signature varies according to patterns that don't correlate with known volcanic cycles. The thermal output increases and decreases following rhythms that suggest deep geological processes operating on timescales much longer than conventional geothermal systems. The secret of Deception Island's hot springs may lie not in what we can observe, but in the complex interactions between systems we're only beginning to understand. The island serves as a reminder that Antarctica holds thermal mysteries that challenge our assumptions about polar environments. In this frozen realm where impossibility becomes reality, steam continues to rise from waters that exist at the very edge of scientific explanation. Byrd's Hollow Earth Hypothesis. When Admiral Richard E. Byrd returned from his 1947 Antarctic expedition, he spoke of lands beyond the pole that defied every map ever drawn. According to diary entries that surfaced decades later, Byrd claimed to have flown over territories of green valleys and mammoth creatures, guided by craft that moved without wings. The establishment dismissed these accounts as altitude sickness or elaborate hoax. Yet Byrd's reputation as one of America's most decorated polar explorers made the claims impossible to ignore entirely. The hollow earth theory didn't begin with Byrd. It emerged from centuries of human curiosity about what lies beneath our feet, gaining scientific momentum in the 1600s when astronomer Edmund Halley proposed that Earth contained nested spheres. By the 1800s, American businessman John Cleve Symmes Jr. had refined the concept, suggesting polar openings that led to an interior world complete with its own sun. Symmes lobbied Congress for funding to mount an expedition, convinced that ships could sail directly into the Earth's core through openings at both poles. What makes Byrd's account particularly compelling is the precision of detail in the alleged diary entries. He describes flying his aircraft over the North Pole in 1947, when his magnetic compass began spinning wildly and the landscape below transformed from ice to green valleys with flowing rivers. According to these writings, beings of advanced intelligence intercepted his aircraft, landing him in a world of technological marvels hidden beneath the polar ice. These entities, described as tall and fair-haired, allegedly warned Byrd about humanity's destructive path and sent him back with a message for the surface world. The U.S. Navy's Operation Highjump, launched just months after Byrd's supposed encounter, has fueled decades of speculation. This massive Antarctic expedition included 4,700 personnel, 13 ships, and 23 aircraft, an unusually large force for what officials described as a training exercise and scientific mission. Byrd commanded the operation, which was scheduled to last 8 months, but terminated abruptly after just 2. When Byrd returned to the United States, he gave a cryptic interview to a Chilean newspaper, speaking of vast lands beyond the poles that could prove valuable in future warfare. The diary itself presents puzzling inconsistencies. Handwriting analysis remains inconclusive, and no original documentation has ever been independently verified. Yet the narrative contains technical aviation details that align perfectly with Byrd's known expertise and flying style. The descriptions of underground civilizations echo ancient myths from cultures worldwide: the Tibetan belief in Shambhala, the Hindu concept of Agartha, Norse legends of hidden realms beneath the ice. Either someone crafted an extraordinarily sophisticated hoax, or Byrd genuinely believed he had encountered something beyond conventional understanding. Modern seismology has mapped Earth's interior with increasing precision, revealing a molten core surrounded by layers of rock and magma. This evidence seemingly contradicts hollow Earth theories, yet gaps in our geological knowledge persist. The deepest human-made hole, Russia's Kola super-deep borehole, penetrated only 12 kilometers into the Earth's crust, barely scratching the surface of a planet with a radius exceeding 6,370 kilometers. Antarctic ice sheets, some over 4 kilometers thick, could theoretically conceal vast subterranean systems. Byrd's Antarctic expeditions produced legitimate scientific discoveries that advanced polar research. His team documented previously unknown mountain ranges, mapped thousands of square kilometers of unexplored territory, and collected geological samples that revealed Antarctica's ancient history. This solid scientific foundation makes his alleged hollow Earth encounters more perplexing. Why would a respected explorer risk his reputation with claims of underground civilizations and advanced beings? The timing of Byrd's supposed encounters coincides with humanity's entry into the atomic age. His alleged underground contacts expressed concern about nuclear weapons, warning that continued atomic testing could threaten both surface and subsurface worlds. This environmental message, delivered through the hollow Earth narrative, anticipated ecological concerns that wouldn't gain mainstream recognition until decades later. The coincidence raises questions about whether Byrd's account reflected genuine prophetic insight or simply the anxieties of a thoughtful observer watching humanity harness devastating new technologies. Geographic anomalies in polar regions continue to challenge conventional understanding. Satellite imagery has revealed massive underground lake systems beneath Antarctic ice, some containing liquid water warmer than surface temperatures. These discoveries don't validate hollow Earth theories, but they demonstrate that our planet's polar regions harbor secrets that modern science is only beginning to uncover. The psychological appeal of hollow Earth concepts reflects deeper human needs to believe in hidden wonders and undiscovered frontiers. As surface exploration eliminated blank spaces on maps, the imagination turned inward, seeking mystery in the depths below. Byrd's alleged encounters satisfy this longing, while addressing contemporary fears about technological progress and environmental destruction. The underground beings serve as both judges and guardians, offering wisdom that surface humanity appears to lack. Critics point out that Byrd's supposed diary entries didn't surface until decades after his death in 1957, making verification impossible. The language and concepts align suspiciously well with New Age spirituality and UFO mythology that gained popularity in the 1960s and 1970s. Yet believers counter that suppression of such extraordinary claims would be expected, given their potential to disrupt established scientific and political paradigms. Whether Byrd actually flew over green valleys and met advanced beings beneath the ice may matter less than what his story reveals about human consciousness at a crucial historical moment. The hollow Earth narrative captures the tension between scientific rationalism and mythic imagination, between the world we think we know and the mysteries that continue to elude our understanding. In the vast whiteness of Antarctica, where reality becomes fluid and the familiar rules of existence no longer seem to apply, perhaps the line between discovery and vision dissolves entirely. Antarctica remains our planet's greatest repository of secrets, a continent where the extraordinary becomes possible and the impossible seems merely improbable. Admiral Byrd's legacy encompasses both his documented scientific achievements and his mysterious claims of worlds beyond conventional maps, reminders that in the frozen depths of Earth's most remote continent, wonder and mystery still reign supreme. Alien visitors and UFO theories. The most isolated continent on Earth has become the unlikely epicenter for some of the world's most compelling UFO encounters. When trained scientists, military personnel, and veteran researchers begin reporting identical phenomena in the same remote location, the conversations shift from casual speculation to careful documentation. Tonight, we follow these accounts into Antarctica's endless sky. Dr. Elena Vasquez still remembers the exact moment her atmospheric research took an unexpected turn, December 15, 2019, at McMurdo Station. She was calibrating equipment for a routine weather balloon launch when three distinct objects appeared on her tracking screen, objects that moved in ways that defied every principle of conventional flight she understood. Her initial report, filed with the National Science Foundation, describes metallic disc-shaped forms maintaining perfect formation at altitudes where no known aircraft should operate. The objects demonstrated instantaneous directional changes, hovering capabilities in winds exceeding 60 miles per hour, and heat signatures that registered as completely cold against the thermal backdrop of the Antarctic atmosphere. What made Dr. Vasquez's account particularly compelling wasn't just her credentials as a meteorologist with 15 years of polar research experience. Two other researchers, working independently at different points around McMurdo, recorded identical sightings within the same 40-minute window. Their testimony, cross-referenced through official channels, created a triangulated confirmation that multiple witnesses had observed the same unexplained aerial phenomenon. The sightings weren't isolated to McMurdo Station. Between 2016 and 2021, at least 17 separate incidents were reported across various Antarctic research installations. Researchers at the Belgrano 2 base documented objects emerging from beneath the ice shelf, rising vertically through the air, then disappearing at speeds their instruments couldn't accurately measure. The Argentine meteorological team calculated velocities exceeding 3,000 miles per hour with zero acceleration time. Captain Marcus Reed, who flew supply missions to Antarctic bases for 12 years, encountered what he describes as his most unsettling professional experience during a routine cargo drop in 2020. While approaching Rothera Research Station, his aircraft's navigation systems began experiencing interference patterns he'd never encountered. His radar showed multiple contacts moving in synchronized patterns around his plane, yet visual contact revealed nothing but clear Antarctic sky. The interference lasted exactly 11 minutes. When his instruments returned to normal function, Reed discovered his aircraft had somehow gained altitude without any input from his controls, and his fuel consumption showed readings that defied the basic physics of his flight plan. His co-pilot, Sarah Martinez, independently confirmed every detail of the encounter in her own flight report. These modern accounts echo historical mysteries dating back to early Antarctic exploration. Admiral Richard Byrd's personal journals, portions of which were declassified in 2006, contain references to aircraft that displayed impossible flight characteristics during his 1946-47 Operation Highjump expedition. Byrd's descriptions of silver disc-shaped objects moving at extraordinary speeds above the polar ice align remarkably with contemporary witness testimonies. The declassified documents reveal that military personnel accompanying Byrd's expedition recorded multiple encounters with unidentified flying objects. Lieutenant Colonel James Thompson's mission reports describe objects that appeared to emerge from the ice itself, suggesting possible underground installations or entry points beneath the Antarctic surface. Dr. Michael Chen, who studies atmospheric physics at the University of Colorado, analyzed electromagnetic readings collected from Antarctic research stations over the past decade. His findings identify recurring anomalous energy signatures that correspond directly with reported UFO sightings. These energy patterns, Chen explains, don't match any known natural atmospheric phenomena or human-generated technology. The patterns suggest a form of propulsion that manipulate electromagnetic fields in ways current terrestrial science cannot replicate. Chen's peer-reviewed analysis, published in the Journal of Atmospheric Sciences, stops short of claiming extraterrestrial origins, but acknowledges that the energy signatures represent technology beyond current human capabilities. What adds credibility to these accounts is the consistency of witness descriptions across different time periods. locations, and research teams, the objects are invariably described as metallic, disc-shaped, or triangular, completely silent, and capable of movements that violate known principles of aerodynamics. Multiple witnesses report the same ability of these craft to appear and disappear instantaneously, as though utilizing some form of advanced cloaking technology. The geographic isolation of Antarctica creates unique conditions for such encounters. With minimal air traffic, no commercial aircraft routes, and carefully monitored research activities, the likelihood of conventional aircraft being misidentified approaches zero. The extreme weather conditions that characterize the continent also eliminate most environmental factors that might create optical illusions or atmospheric distortions. Dr. Jennifer Walsh, a psychologist who studies witness reliability in extreme environments, spent 2 seasons at Antarctic research stations interviewing personnel who reported unusual sightings. Her psychological evaluations found that witnesses demonstrated high credibility markers, showed no signs of environmental stress that might compromise their judgment, and maintained consistent accounts even under detailed questioning months after their experiences. The implications extend beyond simple sightings. Some researchers theorize that Antarctica's unique position as Earth's most untouched continent might make it an ideal location for extraterrestrial observation or research. The continent's ice provides natural preservation of atmospheric and biological samples spanning millions of years, potentially offering valuable scientific data to any advanced civilization studying planetary development. Several ufologists have proposed that the Antarctic Treaty of 1959, which restricts military activities and establishes the continent as a zone dedicated to peaceful scientific investigation, might serve dual purposes. While officially protecting Antarctica's environment, the treaty also limits the number of personnel and activities that might interfere with or witness extraterrestrial operations. The frequency of reported sightings has increased significantly with the expansion of Antarctic research activities and the deployment of more sophisticated monitoring equipment. As technological capabilities improve and more personnel spend extended periods on the continent, the number of documented encounters continues to grow. Whether these accounts represent evidence of extraterrestrial visitation, advanced terrestrial technology being tested in remote locations, or atmospheric phenomena not yet understood by conventional science, remains an open question. What's certain is that trained, credible observers continue to report experiences that challenge our understanding of what's possible in Earth's most mysterious continent. The Antarctic sky keeps its secrets well, but those who work beneath it are watching, and occasionally, something watches back. The hidden freshwater aquifers. Deep beneath Antarctica's frozen surface, scientists have discovered something that defies every model we have about water distribution in polar regions. Vast networks of liquid freshwater flowing through underground channels that shouldn't exist, yet satellite data confirms they're there. Dr. Elena Vasquez first noticed the anomalies in 2019 while analyzing gravitational field measurements over West Antarctica. The readings showed density variations that could only mean one thing: massive amounts of liquid water flowing beneath ice that's been frozen for millions of years. Her colleagues initially dismissed the data as instrument error, but when 3 independent satellite systems produced identical results, the scientific community had to confront an uncomfortable truth. These aren't small underground streams we're talking about. The aquifer systems beneath Antarctica contain more fresh water than all of North America's Great Lakes combined. Rivers flowing in perpetual darkness, following paths carved by forces we don't yet understand. The water remains liquid, despite surface temperatures that would freeze exposed flesh in minutes. What keeps these hidden rivers from turning to ice? The most obvious answer would be geothermal heat from volcanic activity below. But thermal imaging reveals something puzzling. The aquifers don't follow geological hotspots. Instead, they form intricate patterns that seem almost deliberate, networks of channels connecting distant regions with surgical precision. In 2021, researchers from the British Antarctic Survey attempted to drill down to one of these freshwater channels. 300 feet below the surface, their equipment detected flowing water. But when they finally broke through, the drill hit open space, not the confined flow they expected, but what appeared to be an underground cavern system filled with moving water. Dr. Michael Thornton led that drilling expedition. He described the moment their probe descended into the void as the most unsettling experience of his scientific career. The cavern they discovered measured over 200 feet in diameter. Sonar mapping revealed it connected to at least 6 other chambers of similar size, an underground cathedral of liquid water, hidden beneath ice that predates human civilization. More disturbing still, the water wasn't behaving normally. Standard freshwater at those temperatures should flow predictably, following gravity and pressure gradients, but acoustic analysis showed currents moving in directions that violated basic physics. Water flowing uphill, circular patterns that suggested some unknown force was driving the circulation. Temperature readings from deep probe sensors revealed another impossibility. The water maintained a constant 34 degrees Fahrenheit, exactly 2 degrees above freezing, not gradually warming as they descended toward geothermal sources, but maintaining that precise temperature throughout the entire network, as if something was regulating it. The age of this water poses its own mystery. Isotope analysis suggests it's been isolated from surface contact for at least 400,000 years, older than our species. Yet it shows none of the mineral concentrations you'd expect from such ancient groundwater. Instead, it demonstrates purity levels that seem almost filtered. Dr. Vasquez's team made an even stranger discovery when they began mapping the full extent of these aquifer networks. The hidden rivers form geometric patterns when viewed from above, hexagonal configurations that repeat across thousands of square kilometers. Natural processes don't create such regularity. Rivers meander. Groundwater follows the path of least resistance. But Antarctica's hidden freshwater flows in formations that look almost engineered. What's pumping this water through such organized channels? The energy required would be enormous. There's no known geological process that could maintain such circulation patterns across continental distances. Yet the acoustic data is undeniable. These underground rivers have been flowing for millennia. Recent studies have detected something even more concerning. The aquifer levels are rising. Measurements taken over the past 5 years show a steady increase in water volume throughout the system. Not the gradual accumulation you'd expect from melting surface ice, but rapid expansion that suggests an active source. Something is feeding these hidden rivers from below. Climate models can't account for this much liquid freshwater existing beneath Antarctic ice. The presence of these aquifers means our calculations about global water distribution could be off by hundreds of trillions of gallons. Freshwater we never knew existed, following rules we don't understand. But perhaps the most puzzling aspect isn't the water itself, it's what lives in it. Preliminary biological sampling detected microscopic life forms that shouldn't exist in such an environment. Single-celled organisms that show no genetic relationship to any known Antarctic species, as if they evolved in complete isolation from the rest of Earth's biosphere. Dr. Jennifer Walsh, a microbiologist with the Antarctic Research Program, spent 2 years analyzing these water samples. Her findings challenge everything we know about life's limits. These organisms thrive in conditions that would kill most earthly bacteria: complete darkness, near-freezing temperatures, and pressure levels that compress organic matter. Yet they not only survive, they multiply. Genetic sequencing revealed DNA sequences that don't match any database, close enough to terrestrial life to be biological, but different enough to suggest either millions of years of isolated evolution, or something else entirely. Dr. Walsh's published papers refer to them as non-analogous life forms. Scientists' careful way of saying they found something that shouldn't exist. The implications extend beyond biology. If Antarctica contains vast networks of hidden freshwater, it changes our understanding of how water moves through the planet's systems. Ocean currents, weather patterns, and climate stability all depend on accurate water distribution models. Models that didn't account for an entire continental aquifer system. Government agencies have classified much of the recent data as environmentally sensitive. Research permits for deep drilling operations now require security clearances. The official explanation involves concerns about contaminating pristine ecosystems, but scientists familiar with the findings suggest something more complex is at work. The hidden freshwater aquifers of Antarctica represent more than just a geographical discovery. They're evidence that our planet still holds secrets we're only beginning to comprehend. Rivers flowing in eternal darkness, carrying life forms that challenge our definition of biology itself. waters that have remained hidden beneath the ice since before humans walked the Earth, and they're still flowing, following their geometric patterns through chambers we've never seen, maintaining their impossible temperature, rising towards some unknown purpose. The frozen continent keeps its secrets well, but the water beneath is patient. It's waited 400,000 years already. What else might it be waiting for? The riddle of the snow cruiser. In 1940, a mechanical behemoth the size of a Greyhound bus rolled off the assembly line in Chicago, destined for the most inhospitable place on Earth. The Antarctic snow cruiser weighed 55 tons, stretched 75 feet from nose to tail, and carried enough fuel to travel 5,000 miles without stopping. Its designers called it the ultimate polar exploration vehicle. The press dubbed it a land battleship for science. What they couldn't have predicted was that within months of reaching Antarctica, this marvel of American engineering would become one of the continent's most enduring puzzles. The snow cruiser emerged from the ambitious mind of Admiral Richard Byrd, who envisioned a mobile base capable of crossing Antarctica's vast interior. The Armour Institute of Technology took up the challenge, creating a vehicle unlike anything the world had seen. 4 massive tires, each 10 feet tall and nearly 3 feet wide, supported a cabin equipped with machine shop, darkroom, radio station, and living quarters for 5 men. 2 aircraft could be stored on its roof, launched and retrieved using an innovative ramp system. The engineering specifications read like science fiction made real. Diesel-electric motors powered each wheel independently. The vehicle could theoretically climb a 24-degree slope and ford streams 4 feet deep. Inside, generators provided electricity for lights, radio equipment, and scientific instruments. A galley, bunks, and even a small library transformed the machine into a self-contained expedition base. But the snow cruiser's first test came not in Antarctica's frozen wilderness, but on the streets of Washington, D.C. During a publicity stop at the White House, the massive vehicle became stuck trying to climb a modest incline. The tires, designed for snow and ice, couldn't grip ordinary pavement. Engineers quickly attributed the problem to insufficient tire pressure and pressed forward with their plans. The journey to Antarctica began in October 1940, when the snow cruiser was loaded aboard the cargo ship North Star. The vessel barely accommodated the enormous machine, requiring careful calculation to maintain proper weight distribution. After weeks at sea, the ship reached the Bay of Whales, where ice conditions forced an immediate and treacherous unloading process. What happened next revealed the first signs of the mystery that would engulf the snow cruiser. As the massive vehicle rolled off the ship onto Antarctic ice, it immediately began to struggle. The smooth tread tires, engineered for snow traction, proved nearly useless on the hard-packed ice surface. The snow cruiser could barely achieve forward momentum, managing only a fraction of its designed speed. Thomas Poulter, the expedition's second-in-command, and the snow cruiser's chief advocate, attempted various solutions. Teams tried running the vehicle in reverse, discovering it performed marginally better in that configuration. They experimented with tire chains, adjusted tire pressure, and modified the engine settings. Nothing provided the traction needed for effective polar travel. Within days of its arrival, the snow cruiser had traveled fewer than 100 miles from its landing point. The vehicle that was supposed to cross continents found itself relegated to stationary duty as a radio station and temporary shelter. Its aircraft proved more valuable than the vehicle itself, conducting aerial surveys while the land cruiser remained largely immobile on the ice. The expedition documented these setbacks with surprising thoroughness. Radio logs, mechanical reports, and personal journals recorded the growing frustration with their technological marvel. What emerges from these records is not just a story of engineering miscalculation, but something more puzzling. The snow cruiser's problems seemed to compound in ways that defied the expertise of its experienced crew. Mechanical issues began appearing that hadn't manifested during stateside testing. Electrical systems experienced unexplained failures in the Antarctic environment. The vehicle's heating system, crucial for equipment operation and crew survival, proved inadequate for the extreme conditions. Radio equipment suffered interference that technicians attributed to atmospheric conditions unique to the polar region. The crew adapted as best they could, using the snow cruiser as a base camp while conducting their scientific mission through other means. They gathered meteorological data, performed geological surveys, and mapped previously unknown areas of the Ross Ice Shelf. The expedition accomplished many of its scientific objectives, but the centerpiece vehicle remained a costly disappointment. When the expedition concluded in early 1941, logistics and international circumstances prevented the snow cruiser's return. World War II had begun, and naval resources were needed elsewhere. The decision was made to abandon the vehicle temporarily, with plans to retrieve it after the war ended. The snow cruiser was carefully prepared for extended storage. Fuel tanks were drained, systems were shut down, and the vehicle was covered with tarps to protect it from the elements. Radio operator Earl Peirce made the final transmission from the snow cruiser on January 12, 1941, noting the vehicle's location and condition for future recovery efforts. But when post-war expeditions returned to the Bay of Whales, they found something unexpected. The snow cruiser had vanished. Initial search efforts focused on the last recorded position, but the Antarctic landscape had changed dramatically. Ice shelves had shifted, snow had accumulated, and familiar landmarks had disappeared. The 55-ton vehicle seemed to have been swallowed by the continent itself. Subsequent expeditions have reported various theories about the snow cruiser's fate. Some suggest it was buried under decades of accumulated snow, preserved beneath the ice like a mechanical time capsule. Others believe the vehicle was carried away when sections of the Ross Ice Shelf calved into the ocean, taking the snow cruiser with them to the bottom of the Antarctic seas. Satellite imagery and ground-penetrating radar have been employed in modern search efforts, but Antarctica's vast scale makes systematic searching nearly impossible. The continent spans 14 million square kilometers, much of it constantly changing as ice moves, accumulates, and breaks away. What makes the snow cruiser's disappearance particularly intriguing is how completely it vanished. Unlike smaller artifacts that might be consumed by the ice, a vehicle of this size should have left detectable traces. Metal components don't simply disappear, even under extreme conditions. The massive tires alone should create identifiable signatures for modern detection equipment. The snow cruiser's legacy extends beyond its mechanical failures and mysterious disappearance. It represents humanity's perpetual struggle to impose technology upon nature's most unforgiving environments. The vehicle embodied mid-20th century confidence in engineering solutions, yet Antarctica humbled it within days of arrival. Somewhere in the frozen wilderness, 55 tons of American engineering ambition remain hidden, waiting for discovery. The Antarctic snow cruiser's riddle endures, a reminder that even our most carefully planned expeditions into the unknown can become mysteries themselves. Shackleton's lost endurance. After 107 years beneath the Antarctic ice, the Endurance emerged from the Weddell Sea in March 2022, looking as though her crew had abandoned ship just yesterday. The preservation defied every maritime archaeologist's expectations. Wood intact, the ship's wheel still mounted, paint still clinging to her hull in impossible detail. Ernest Shackleton's ship wasn't supposed to survive. When pack ice crushed her hull in 1915, she should have disintegrated like countless other vessels claimed by polar waters. Instead, she became something else entirely, a time capsule that challenges our understanding of decay, preservation, and the Antarctic's capacity to suspend the natural order. The Discovery team found her sitting upright on the seafloor, 10,000 feet down, her masts long since snapped away, but her structure fundamentally sound. Marine biologist Dr. Michelle Taylor described the scene as the finest wooden shipwreck she'd ever encountered. But fineness doesn't capture what the cameras revealed. The Endurance looked waiting, as if she'd been holding space beneath the ice, keeping Shackleton's story alive in her timbers. Temperature played its role, certainly. The Weddell Sea maintains near-freezing conditions year-round, slowing bacterial decay to an almost geological pace. But other ships have sunk in similar waters and emerged as scattered debris fields. The Endurance retained her integrity in ways that push the boundaries of what polar preservation should achieve. Her discovery location itself presents puzzles. The search team used Frank Worsley's navigational records, the ship's captain whose celestial calculations from 1915 guided modern GPS coordinates with uncanny accuracy. Worsley had estimated their position using sextant readings taken while the ice carried them helplessly across the sea. Those century-old calculations, made under desperate circumstances, proved accurate within a 4-mile radius, But Worsley's precision raises questions about the crash itself. His logs describe the ice as alive, moving with purpose rather than random current. The Endurance didn't simply get caught in pack ice. She was systematically crushed by pressure that seemed to target her specifically. Other vessels in the region during that period managed to break free. The Endurance found herself trapped by ice formations that defied the normal flow patterns of the Weddell Sea. The ship's final position, nearly 10,000 feet down, sits atop what researchers now recognize as an unusual seafloor formation. Sonar mapping reveals geometric patterns beneath the sediment, too regular for natural geological processes, too ancient for human origin. The Endurance came to rest directly above these formations, as if the sea itself guided her descent. Inside the wreck, preservation reaches almost supernatural levels. Leather boots still retain their shape and stitching, rope coiled exactly as the crew left it. Most remarkably, the ship's library survived, books whose pages remain readable, their ink unfaded despite decades of submersion. Marine environments destroy organic materials with ruthless efficiency. The Endurance preserved them with surgical precision. Dr. Mensoon Bound, the mission's director of exploration, documented artifacts that shouldn't exist in recognizable form. Personal effects showed no signs of the bacterial films that typically coat submerged objects within months. Metal showed minimal corrosion. Most puzzling, wooden structures retained flexibility. Timber that should have become brittle as stone could still bend under pressure. The preservation pattern isn't uniform though. Certain sections of the ship show expected deterioration, while others appear frozen in time. The galley, where the crew prepared their final meals before abandoning ship, looks ready for immediate use. The engine room, by contrast, shows standard corrosion patterns, as if the sea chose which memories to preserve and which to let fade. Shackleton's own cabin yielded the most intriguing discoveries. His personal effects lay arranged with peculiar orderliness, not the hasty abandonment you'd expect from a sinking ship, but careful placement. His navigation instruments remained precisely positioned on his desk. Charts still showed his planned route across Antarctica, with notations in his handwriting that don't match any known expedition records. These charts depict geographical features that didn't appear on official maps until satellite surveys of the 1960s. Inland mountain ranges, hidden valleys, subglacial lake systems, knowledge that Shackleton seemingly possessed decades before their documented discovery. The charts bear his signature and use period-appropriate ink, yet contain information that shouldn't have existed in 1915. The crew's abandonment of the Endurance followed patterns that maritime historians find increasingly difficult to explain. Typically, sailors fleeing a sinking vessel take essential survival equipment in chaotic haste. The Endurance crew left behind valuable supplies while carefully preserving seemingly random personal items. They abandoned food stores but saved photograph albums, left practical tools but took scientific instruments of questionable survival value. Frank Hurley, the expedition photographer, documented their departure with images that reveal curious details. The crew appears calm, not the desperate urgency of men fleeing disaster, but the measured movements of people following a predetermined plan. They loaded their lifeboats with specific cargo arrangements that prioritize documentation over sustenance. Recent analysis of Hurley's photographs reveals details invisible to earlier researchers. Enhanced imaging shows structures in the background ice, geometric formations that extend far beyond the Endurance's immediate location. The pack ice that trapped them wasn't random accumulation, but organized patterns stretching to the horizon. Patterns with mathematical precision. The Endurance Discovery Team found evidence of these formations still intact on the sea floor. Sonar reveals corridors of raised sediment radiating outward from the wreck site, ancient channels that predate the ship by millennia, yet seem designed to guide objects to this specific location. Shackleton wrote in his private journals about dreams that began weeks before the ice trapped them, dreams of the ship resting on the ocean floor, perfectly preserved, waiting for discovery by future generations. He described these visions with troubling accuracy, details that match the actual wreck site with impossible precision. The Endurance holds more than historical artifacts. She preserves questions that challenge our understanding of preservation, prediction, and the Antarctic's relationship with human ambition. Her timbers contain stories that extend far beyond Shackleton's failed crossing attempt, stories written in wood and ice, waiting for us to develop the wisdom to read them. In the deepest part of the coldest sea, The endurance keeps her vigil, perfectly preserved, impossibly intact, eternally patient. The ancient cosmic rays dilemma. When cosmic ray detectors buried beneath 3 miles of Antarctic ice began recording impossible readings in 2016, physicists worldwide found themselves staring at data that challenged the very foundation of particle physics. The instruments were designed to capture the universe's most elusive messengers, particles that had traveled billions of years through space to reach Earth. What they found instead were signals pointing straight up from the ice, defying everything we thought we knew about cosmic radiation. Antarctica serves as Earth's pristine laboratory for cosmic ray research. The continent's magnetic field deflection, combined with its crystal-clear atmosphere and minimal human interference, creates ideal conditions for detecting these high-energy particles from deep space. Research stations scattered across the frozen continent house some of the most sophisticated detection equipment ever built, instruments capable of tracking particles so rare that only a handful strike each square kilometer of Earth every century. The Antarctic muon and neutrino detector array, known as AMANDA, was the predecessor to the current IceCube Neutrino Observatory. Scientists drilled deep into the glacier, lowering strings of photomultiplier tubes into the pristine ice. The ice itself becomes the detector, flashing with brief blue light whenever a cosmic ray interaction occurs. It's an elegant solution, using nature's own 3-billion-year-old ice as a massive particle physics laboratory. But the data emerging from these frozen depths tells a story that doesn't fit our current understanding of the cosmos. Standard cosmic rays arrive from all directions, their paths bent and scattered by magnetic fields throughout the galaxy. They should create a roughly uniform shower of secondary particles as they strike Earth's atmosphere. The Antarctic detectors, however, have recorded multiple instances of high-energy particles appearing to emerge from deep within the Earth itself. Doctors Derek Fox from Penn State University was among the first to publicly acknowledge the anomaly. The detected particles matched the energy signature of cosmic ray secondaries, but their trajectory was all wrong. Instead of cascading down from space, these particles appeared to be shooting upward through the planet. The only known particles capable of passing through the entire Earth are neutrinos, but the detected signals didn't match neutrino characteristics. The Pierre Auger Cosmic Ray Observatory in Argentina had recorded similar anomalies years earlier, but the Antarctic data provided unprecedented clarity. The particles weren't random flukes, they followed patterns. Certain energy levels appeared more frequently, and the timing showed subtle correlations with astronomical events. When high-energy gamma-ray bursts occurred in distant galaxies, the upward-traveling Antarctic particles increased in frequency. One particularly intriguing case occurred in March 2018. The IceCube detector recorded a series of upward-traveling particles with energies exceeding anything previously observed from cosmic ray interactions. The timing coincided with a massive solar flare, but the particle signatures didn't match any known solar radiation effects. More puzzling still, identical readings were recorded simultaneously at research stations separated by over 800 miles of ice. Theoretical physicists have proposed several explanations, each more extraordinary than the last. Some suggest the particles represent evidence of dark matter interactions deep within Earth's core. Others theorize about unknown decay processes involving exotic matter states. A few researchers have even suggested the data indicates dimensional bleeding, particles crossing from parallel universes into our reality. The magnetic anomaly beneath Wilkes land adds another layer of complexity to the cosmic ray mystery. This massive gravitational and magnetic disturbance, buried beneath miles of ice, seems to correlate with the most intense upward particle detections. When researchers mapped the trajectory paths of the anomalous particles, a significant percentage traced back to the region directly above the Wilkes land anomaly. What makes the Antarctic cosmic ray dilemma particularly unsettling is the quality of the data. These aren't fringe measurements from questionable equipment. The detection arrays represent the pinnacle of particle physics technology, maintained by international teams of researchers and cross-verified through multiple independent systems. The anomalous readings have been replicated, confirmed, and studied for over 6 years without a satisfactory explanation. The implications extend far beyond particle physics. If particles are indeed traveling upward through the Earth, It suggests unknown physics at work in our planet's core. The energy requirements for such phenomena would be staggering, implying processes or materials completely outside our current scientific understanding. Some researchers have begun investigating whether the particles might be artificial in origin, the byproduct of technology, rather than natural cosmic processes. Temperature fluctuations in the ice surrounding the detector arrays have revealed another puzzling correlation. Areas showing the highest concentrations of upward particle detection also demonstrate unexplained thermal variations. The temperature differences are subtle, but consistent, creating pockets of slightly warmer ice in patterns that mirror the particle trajectories. The international scientific community remains divided on interpretation. Conservative physicists argue that unknown atmospheric or geological processes must be creating false readings. They point to possible contamination from the detector installation process, or unforeseen electromagnetic interference from the Antarctic environment. Progressive researchers counter that the data is too consistent and widespread for simple experimental error. Recent attempts to correlate the Antarctic anomalies with cosmic ray data from other polar regions have yielded mixed results. The Arctic research stations show occasional similar readings, but at much lower frequencies and intensities. This geographical specificity adds weight to theories involving unique Antarctic geological features, particularly the massive ice sheet and underlying continental structure. Perhaps most intriguingly, the Vostok ice core drilling project has revealed microscopic particles embedded in ancient ice layers that match the energy signatures of the upward-traveling cosmic rays. These particles, locked in ice formed over 400,000 years ago, suggest the Antarctic cosmic ray phenomenon has been occurring for far longer than modern detection equipment has existed. The cosmic ray dilemma transforms Antarctica from merely Earth's most remote continent into a window onto physics we don't yet comprehend. Every day, buried detectors continue recording impossible data while researchers struggle to construct theories capable of explaining what they're observing. The ice holds more than frozen water. It may contain evidence of cosmic processes that could revolutionize our understanding of reality itself. In the endless Antarctic night, machines designed to capture the universe's secrets instead reveal mysteries closer to home than anyone expected. The Thiel's remnant mystery. Deep within Antarctica's transantarctic mountain range, a peculiar cluster of peaks rises from the ice, like ancient sentinels guarding secrets from Earth's distant past. The Thiel Mountains, named after geologist Edward Thiel, who died tragically in a crevasse accident while studying them in 1961, harbor geological formations that shouldn't exist where they do. These aren't simply old rocks buried in ice. They're fragments of a planet that once looked nothing like the world we know today. When researchers first examined core samples from the Thiel Mountains in the late 1970s, they discovered something that made them question everything they understood about continental drift. The rock formations contained mineral compositions identical to geological structures found in southern Africa, South America, and Australia. Not similar, identical. Down to the molecular level, these Antarctic peaks matched stones separated by thousands of miles of ocean. Dr. Margaret Chen, a structural geologist who spent 3 seasons studying the Thiels, described her first encounter with the data as profoundly unsettling. The isotopic signatures she was seeing suggested these mountains had once been connected to land masses that are now on entirely different continents. But the timeframes didn't align with conventional models of how Gondwana, the ancient supercontinent, broke apart. The mystery deepens when you examine the Thiel's internal structure. Using ground-penetrating radar, teams discovered that beneath the visible peaks lies a vast network of interconnected rock formations, extending hundreds of miles underground. These subterranean structures form patterns that geological surveys have identified in only 3 other places on Earth, each separated by oceanic distances that would have taken millions of years to traverse through continental drift. Yet radiocarbon dating of mineral deposits within these formations tells a different story. The evidence suggests these connections existed far more recently than our models of tectonic movement would allow. Some formations appear to have been severed from their counterparts as recently as 2 million years ago, a geological blink of an eye that challenges fundamental assumptions about how continents move. The Thiel Mountains also contain something else, that has geological teams baffled, fossilized root systems from plant species that shouldn't have been able to survive in Antarctica's climate, even during its warmer periods. These aren't the temperate forest remnants typically found in Antarctic fossil records. These are root systems from tropical vegetation, plants that required year-round warmth and humidity levels that, according to climate models, never existed in this region of Antarctica. Dr. Robert Kellerman, who led the 2019 Paleobotanical Survey of the Thiels, found himself confronting data that didn't fit any established timeline. The fossilized root networks showed evidence of rapid preservation, as if an entire ecosystem had been flash-frozen while still actively growing. Carbon dating placed these tropical plant remains at approximately 15,000 years old, a time when Antarctica should have been locked in deep ice age conditions. But perhaps the most perplexing aspect of the Thiel Mountains lies in their magnetic properties. Unlike any other mountain range on Earth, the Thiels display what geophysicists call inverted magnetic polarity. Their magnetic field runs opposite to both Earth's current magnetic field and the regional magnetic patterns of the surrounding Antarctic landscape. This suggests they formed during a period when Earth's magnetic poles were reversed, but they show no evidence of the gradual magnetic transition that should accompany such ancient formations. Recent satellite magnetometry has revealed even stranger details. The magnetic anomaly beneath the Thiel Mountains extends deep into the Earth's crust, forming what appears to be a perfectly circular pattern nearly 200 miles in diameter. Natural geological processes don't typically create such geometrically precise formations. The magnetic signature resembles what you might expect from a massive metallic object buried deep beneath the mountains, but natural metal deposits don't form in perfect circles. Teams attempting to drill core samples from the magnetic anomaly's center have encountered unexpected resistance. At depths where the drill should be passing through sedimentary rock, the equipment hits something that resists penetration. Multiple drilling attempts have yielded the same result: normal rock formations until reaching the anomaly's center, then complete obstruction at precisely the same depth across different drilling sites. The few mineral samples successfully extracted from the edge of this magnetic anomaly contain trace elements not typically found in Antarctic geology. Specifically, unusually high concentrations of rare earth metals that are more commonly associated with meteorite impacts. Yet there's no impact crater, no evidence of cosmic collision, just these scattered metallic traces embedded within otherwise ordinary mountain rock. Local weather patterns around the Thiel Mountains also behave unusually. Atmospheric pressure readings frequently spike and drop without corresponding changes in temperature or wind patterns. GPS equipment experiences accuracy drift when operated near the magnetic anomaly. Radio communications develop interference that follows no predictable pattern, sometimes crystal clear, sometimes completely blocked, with transitions happening instantaneously rather than gradually. The indigenous knowledge traditions of the region, passed down through generations of explorers and researchers who have worked in Antarctica, speak of the Thiels as a place where time moves differently. While this might sound like folklore, there's scientific data that's difficult to dismiss. Atomic clocks transported to various locations around the Thiel Mountains have recorded minute but measurable variations in timekeeping accuracy, variations that correspond with proximity to the magnetic anomaly. Dr. Elena Vasquez, a quantum physicist who joined the 2021 research expedition, documented temporal variations of several nanoseconds across different locations within a 5-mile radius of the anomaly's center. These measurements are reproducible and consistent, yet they represent temporal distortions that shouldn't occur in normal geological settings. The implications of what lies beneath the Thiel Mountains extend beyond simple geological curiosity. If these formations represent evidence of Earth's continental arrangement being fundamentally different from our current models, it would require rewriting significant portions of geological and climatological history. And if the magnetic anomalies and temporal distortions are connected to something specific buried beneath these peaks, well, that opens questions that current Earth sciences aren't equipped to answer. The Thiel Mountains stand as a reminder that even in our satellite-mapped, ground-penetrating radar-surveyed world, entire mountain ranges can harbor mysteries that challenge our understanding of how planets form, how continents move, and how time itself behaves under certain geological conditions. Antarctica's multi-million-year ice record, 3 miles beneath your feet, time moves differently. In 2013, researchers at Princeton made a discovery that forced climatologists to reconsider everything they thought they knew about Earth's memory. They had successfully extracted ice that was 2.7 million years old, ice that contained atmospheric data from before humans walked upright, before the great ice ages shaped our continents, before our planet resembled anything we might recognize today. The Dome Fuji Ice Core project had been running for decades, each year bringing teams deeper into Antarctica's frozen archive, but nobody expected to find themselves holding fragments of air that dinosaurs might have breathed. When Dr. Kenji Kawamura examined those samples under laboratory conditions, the atmospheric readings defied current models of how Earth's climate should behave over geological time. The ice doesn't lie. Unlike tree rings or sediment layers, ice cores capture actual atmosphere, tiny bubbles of ancient air trapped in crystalline prisons, waiting millions of years for someone to release them. Each bubble contains precise measurements of carbon dioxide levels, methane concentrations, temperature fluctuations, and atmospheric pressure from its era. It's the most accurate climate record we possess, and it extends far beyond recorded human history. What troubles researchers isn't just the age of these samples, it's what they reveal about climate stability. Our current understanding suggests that Earth's climate operates in predictable cycles, shifting between ice ages and warming periods over roughly 100,000 year intervals. The million-year ice record should confirm this pattern. Instead, it reveals something far more chaotic. Dr. Kawamura's team discovered that between 1.2 and 0.9 million years ago, Earth's climate shifted into an entirely different rhythm. The 41,000 year cycles that had dominated for millions of years suddenly stretched into 100,000 year patterns. No existing theory adequately explains this transition. The ice simply documents that it happened, leaving scientists to wonder what force could alter planetary climate cycles so dramatically. The extraction process itself borders on the impossible. Teams drill through ice that accumulated grain by grain over millennia, each layer compacted under the weight of everything that came after. At depths beyond 2 miles, the pressure transforms normal ice into something resembling glass. The drill bits heat from friction, threatening to melt the very samples they're trying to retrieve. Every foot deeper requires exponentially more effort, but the technical challenges pale compared to the interpretive puzzles. In 2019, analysis of 1.5 million-year-old ice revealed atmospheric carbon dioxide levels that fluctuated in patterns completely unlike anything from the past 800,000 years. The variations were more extreme, shifting more rapidly, following rhythms that don't match Earth's orbital cycles or solar output variations. Perhaps most unsettling are the silent periods, stretches of ice, that contain almost no atmospheric bubbles at all. These gaps suggest either catastrophic climate events that prevented normal ice formation, or conditions so extreme that even Antarctica's ice sheets temporarily melted. Either scenario implies a planet capable of changes that would make current global warming concerns seem modest by comparison. The deeper cores reveal other mysteries. Volcanic ash layers appear at depths that don't correspond to any known major eruptions. Dust patterns suggest massive storms that dwarf anything in recorded history. Chemical signatures indicate ocean compositions radically different from today's seas. Each layer tells of an Earth that operated by different rules, under different constraints. Some of the most intriguing discoveries come from the transition zones. Ice formed during periods when the climate shifted from one stable state to another. These samples show that major climate changes didn't happen gradually over thousands of years, as most models predict. They happened within decades, sometimes within years. The ice documents entire climate systems collapsing and rebuilding faster than human civilizations rise and fall. Doctors would Yuko Motoyama, who spent 15 seasons extracting ice from Dome Fuji, describes holding samples that predate human evolution by millions of years. She talks about the strange responsibility of being among the first humans to encounter air that existed before our species, the eerie sensation of releasing gases that had been locked away since before the continents reached their current positions. The implications extend beyond climate science. If Earth's atmospheric systems can shift between fundamentally different operating modes, If stable periods lasting hundreds of thousands of years can end within a human lifetime, then our assumptions about planetary stability may be dangerously naive. The ice suggests that what we consider normal climate behavior represents just one possible configuration among many. Recent advances in ice analysis have revealed even more troubling patterns. Microscopic examination of 2-million-year-old samples shows evidence of atmospheric chemistry that shouldn't have been possible given our understanding of how Earth's systems interact. Oxygen isotope ratios indicate ocean temperatures that conflict with other geological evidence from the same periods. The data is internally consistent within each sample, but collectively, it paints a picture of a planet that doesn't follow the rules. Perhaps most mysteriously, some of the oldest ice cores contain what researchers cautiously term atmospheric anomalies, chemical signatures that don't match any known geological or biological processes. These traces appear consistently across multiple drilling sites, ruling out contamination. They suggest that Earth's ancient atmosphere contained elements or compounds that no longer exist in measurable quantities. The work continues, deeper and older, each core pushing further into Earth's frozen memory. Teams are now targeting ice that may be 5 million years old, samples that would predate the formation of the Panama Land Bridge, reaching back to when Earth's ocean circulation operated entirely differently. But with each breakthrough comes deepening uncertainty. The ice cores don't just record climate history, they reveal how little we understand about the planet we inhabit. They document an Earth capable of rapid, devastating changes, a world where stability is temporary, and the systems we depend on can reorganize without warning. 3 miles beneath Antarctica, millions of years of atmosphere wait in frozen silence, holding secrets about changes that dwarf anything in human experience. The ice remembers everything. The question is whether we're prepared to understand what it's trying to tell us. The significance of the Thwaites Glacier. In February 2021, researchers detected something beneath Thwaites Glacier that fundamentally altered our understanding of ice sheet collapse. The data showed warm water carving cavities the size of Manhattan into the glacier's underside, cavities that hadn't existed just years before. They call it the Doomsday Glacier, though those who study it prefer more clinical terms. Thwaites sits like a massive cork in West Antarctica's ice sheet, holding back enough frozen water to raise global sea levels by over 2 feet. But naming it after Doomsday implies we understand what's coming. The truth is far more unsettling. We don't. The glacier spans an area roughly the size of Florida, yet it's retreating at a pace that defies every model scientists have built. Each year, Thwaites loses approximately 50 billion tons of ice. That's not the mystery, though. Ice sheets have advanced and retreated throughout Earth's history. What baffles researchers is the acceleration and the precision with which nature seems to be dismantling this particular giant. Dr. Kuya Riverman spent 3 months camped on Thwaites' surface in 2019, drilling through nearly half a mile of ice to reach the glacier's base. What her team found there challenges everything we thought we knew about glacial physics. The boundary between ice and bedrock, it's not solid. Instead, they discovered a slush-like layer, neither fully frozen nor completely liquid, that seems to lubricate the glacier's movement toward the sea. This discovery raises uncomfortable questions. Traditional glaciology suggests ice sheets move slowly, predictably, governed by temperature gradients and gravitational flow. But Thwaites behaves more like a living system, responding to oceanic changes with an almost biological sensitivity. When deep ocean currents shift by mere degrees, the glacier reacts within weeks, not decades. The Amundsen Sea, which borders Thwaites' terminus, holds its own secrets. Bathymetric surveys reveal underwater ridges and valleys carved by ice sheets that existed millions of years ago. These ancient pathways tell a story of rapid collapse cycles, periods when massive ice volumes disappeared into the ocean within centuries, not millennia. The geological record suggests Thwaites has done this before. But here's where the mystery deepens. Ice cores from Thwaites contain atmospheric data spanning 68,000 years. Within these frozen archives, scientists have found evidence of abrupt climate transitions, moments when atmospheric conditions shifted dramatically within decades. Some of these transitions coincide with unexplained spikes in cosmic radiation, solar activity fluctuations, and volcanic eruptions on the opposite side of the planet. The correlation seems impossible until you consider Thwaites' unique position. The glacier sits directly opposite the Tibetan Plateau, the world's largest elevated landmass. Some researchers propose that seismic activity in Tibet creates subtle vibrations that propagate through Earth's core, affecting ice stability in Antarctica. It sounds like science fiction, yet seismometers on Thwaites consistently register microtremors that correspond to major earthquakes in Asia. Remote sensing data from 2020 revealed another anomaly. Satellite thermal imaging detected warm spots beneath the glacier that don't correlate with known geological features. These heat signatures appear and disappear in patterns that suggest underground water movement, but the water source remains unidentified. The bedrock beneath Thwaites is supposedly solid granite, yet something is creating cavities and channels where none should exist. Marine biologist Dr. James Patterson made an unexpected discovery while studying waters near Thwaites' ice shelf. His deep-sea cameras captured footage of ancient tree stumps embedded in the glacier's terminal face, preserved in ice for millions of years. Carbon dating revealed these fossilized remains are 15 million years old, predating every accepted timeline for West Antarctic ice sheet formation. The implications cascade beyond glaciology. If Thwaites formed 15 million years ago, then our understanding of Antarctic climate history needs complete revision. More troubling, the preserved organic matter suggests rapid burial. These ancient forests didn't gradually succumb to advancing ice. They were buried catastrophically, flash frozen in positions that indicate sudden, overwhelming ice accumulation. Oceanographic studies around Thwaites reveal another puzzle. Deep water temperatures in the Amundsen Sea are rising faster than global averages, but the heat source isn't atmospheric warming. Isotope analysis indicates this warm water originates from deep ocean currents that shouldn't reach this region. It's as if the ocean's circulation patterns have fundamentally reorganized, channeling tropical heat directly to Antarctica's most vulnerable glacier. The glacier's internal structure defies explanation. Ground-penetrating radar reveals vast hollow spaces within the ice, some large enough to contain cathedral-sized chambers. These voids aren't random. They form geometric patterns that suggest organized flow systems. Glaciologists expected uniform ice density, but Thwaites resembles a complex plumbing network more than a solid ice mass. Current projections suggest Thwaites could collapse within 200 to 500 years, but these timelines assume gradual, predictable processes. The geological record tells a different story, one of sudden threshold events where massive ice sheets disappeared within human lifespans. Sediment cores from the Ross Sea show evidence of rapid ice retreat events that occurred without warning, triggered by mechanisms we still don't understand. Perhaps most unsettling are the acoustic recordings from beneath the glacier. Hydrophones detect sounds, not the expected creaking and grinding of ice movement, but rhythmic pulses that occur in cycles. These acoustic signatures don't match any known glacial phenomena. Some researchers reluctantly admit they sound almost intentional. The data points toward a disturbing possibility. Thwaites isn't simply melting due to climate change. It's responding to forces we haven't identified, geological, oceanographic, or atmospheric triggers that operate on timescales and through mechanisms beyond our current understanding. The glacier seems to be following a script written by processes we're only beginning to recognize. Standing at the edge of what we know about Thwaites Glacier, we face an uncomfortable truth. Our doomsday projections might be wildly optimistic or completely wrong. The glacier holds secrets that could redefine our relationship with planetary systems we thought we understood. And somewhere beneath 2 miles of ice, ancient forests wait in frozen suspension, witnesses to catastrophes we've yet to imagine. Snow Hill Islands preserved dinosaurs. When paleontologists first chipped away the Antarctic ice on Snow Hill Island in 2001, they expected fragments, bone chips, perhaps a vertebra, if fortune smiled. What they found instead was a juvenile hadrosaur, so perfectly preserved that its delicate skull bones remained articulated exactly as they had been 68 million years ago. The creature's eye sockets still held the precise angle of its final moment, and its teeth bore microscopic wear patterns that revealed what it had eaten in its last days. The Discovery team stood in stunned silence for nearly 10 minutes. Dr. Judd Case later described the moment as encountering a sleeping dragon that had simply never woken up. Snow Hill Island sits like a forgotten fragment at the tip of the Antarctic peninsula, where the ice meets the Weddell Sea in an endless dance of freeze and thaw. Most visitors see only white emptiness stretching beyond comprehension. But beneath that deceptive surface lies one of Earth's most extraordinary fossil graveyards, where time stopped not gradually, but with shocking suddenness. The hadrosaur became known as the Antarctopelta oliveroi, and it represented something unprecedented in paleontology. Unlike fossils found in traditional dig sites, where bones scatter and minerals slowly replace organic matter over millennia, Antarctica's specimens emerged as if preserved by some cosmic flash freezing process. Soft tissues remained intact. Stomach contents could be analyzed. Even microscopic cellular structures showed remarkable preservation. What baffled researchers wasn't just the quality of preservation, but the timeline it represented. These creatures lived during the late Cretaceous period, when Antarctica occupied a radically different position on Earth. The continent hadn't yet drifted to its current polar location. Instead, it basked in temperate climates, covered in lush forests where massive dinosaurs roamed beneath towering conifers and primitive flowering plants. The fossil record from Snow Hill Island paints a picture of abundance that feels almost mythical. Plesiosaurs with necks longer than school buses glided through warm seas. Flying reptiles with wingspans rivaling small aircraft soared above dense forests, and walking among them, the hadrosaurs moved in herds across landscapes that bore no resemblance to today's frozen wasteland. But the preservation patterns suggest something more complex than simple climate change. Dr. Ria Alejandra Soto, who spent 3 seasons excavating the site, noticed that many specimens appeared to have died simultaneously, not over decades or centuries, as typically occurs in fossil beds, but within what appeared to be days or weeks of each other. The bones tell stories of creatures caught mid-stride, a small theropod preserved with one leg extended, as if it had been walking when whatever killed it struck. Marine reptiles found far inland, as though massive waves had carried them beyond their normal habitats during some catastrophic event. The fossil arrangements suggested not gradual extinction, but a sudden curtain falling on an entire ecosystem. Carbon isotope analysis of the surrounding rock layers revealed atmospheric changes that occurred within an extraordinarily compressed time frame. Oxygen levels fluctuated wildly. Temperature markers showed rapid oscillations between warm and cold periods. The geological signature resembled a planetary emergency, rather than gradual environmental shift. Perhaps most intriguingly, several specimens showed evidence of rapid growth patterns in their final years. Bone density measurements indicated these creatures had been growing faster than normal, as though some external pressure had accelerated their development. Trees found fossilized alongside them showed similar patterns, growth rings compressed into unusually narrow bands, suggesting environmental stress that pushed biological systems into overdrive. The mystery deepens when compared to fossil sites elsewhere in the world from the same time period. Snow Hill Island specimens display preservation characteristics that remain scientifically unexplained. Organic compounds that should have degraded eons ago persist in measurable quantities. Protein fragments from dinosaur bone have been successfully extracted and analyzed, something that shouldn't be possible after 68 million years under normal circumstances. Some researchers theorize that Antarctica's unique magnetic field properties during the late Cretaceous period created preservation conditions unlike anywhere else on Earth. The continent's position near the paleomagnetic South Pole might have generated electromagnetic fields that fundamentally altered the fossilization process. Others point to the possibility of rapid burial under unusual circumstances. Volcanic ash deposits in the area show signs of massive eruptions that could have entombed entire ecosystems almost instantaneously. But volcanic preservation typically carbonizes organic matter, and Snow Hill Island's fossils show remarkably little thermal damage. The most puzzling aspect involves the apparent behavioral changes visible in the fossil record. Normally solitary species appear to have grouped together in the final layers. Ocean dwellers somehow ended up far from water. Predators and prey were found in impossible proximity, suggesting that normal survival instincts had been somehow overridden or disrupted. Recent expeditions have uncovered even stranger evidence. Microscopic analysis of bone samples revealed cellular structures that appear to have been in the midst of unusual metabolic processes when preservation occurred. Rather than the typical cellular breakdown associated with death, many samples show signs of hyperactive cellular division that stopped abruptly. The implications extend beyond paleontology into fundamental questions about planetary catastrophes and their effects on biological systems. If these creatures experienced some form of global crisis that simultaneously accelerated their growth, altered their behavior, and created unprecedented preservation conditions, then Snow Hill Island represents a snapshot of Earth during one of its most mysterious transitions. What fascinates researchers most is how these perfectly preserved specimens challenge our understanding of deep time itself. Standing before a hadrosaur skull, where individual bone textures remain visible to the naked eye, the 68 million years that separate us from these creatures seem to collapse into irrelevance. The boundary between past and present blurs in ways that make even seasoned scientists question the linear nature of geological time. Each new excavation season brings discoveries that complicate rather than clarify the picture. Fossil hunters working the site report finding preservation so detailed they can distinguish individual muscle fiber orientations. Others describe bone surface textures that appear almost fresh, as though the creatures died recently rather than during the age of dinosaurs. Snow Hill Island continues to yield its secrets reluctantly, each fossil raising more questions than it answers about the final days of Antarctica's ancient inhabitants. Mysterious polynyas in Antarctic seas. In March of 2017, satellite imagery captured something that defied every model scientists had built about Antarctic sea ice behavior. A hole the size of South Carolina had opened in the Weddell Sea's frozen surface, and no one could explain why it was there. The phenomenon has a name that rolls off the tongue like poetry from another world: polynya, derived from the Russian word meaning hole in the ice. These mysterious openings appear where solid ice should reign supreme. What makes this particular polynya so unsettling isn't just its massive scale, but the fact that it appeared in the same location where another inexplicable opening had formed 4 decades earlier, lingered for 3 winters, then vanished without a trace. Dr. Ethan Campbell was analyzing routine satellite data when he first spotted the anomaly. The oceanographer had seen polynyas before. They're common enough near coastlines where warm land meets frozen sea. But this opening sat hundreds of miles from any shoreline, surrounded by ice thick enough to support the weight of polar research stations. The coordinates placed it directly above the Maud Rise, an underwater mountain that rises nearly 2 miles from the ocean floor. Campbell's initial reaction was to check his equipment. Satellite glitches happen, data corrupts, but multiple imaging systems confirmed what seemed impossible: a gaping wound in the ice sheet, dark water reflecting starlight where none should exist. The scientific community calls these deep ocean openings sensible heat polynyas, though the name itself hints at how little we understand them. The theory suggests that warmer water from the ocean's depths somehow rises to melt the surface ice from below. It's a process that requires a delicate balance of temperature, salinity, and current dynamics that shouldn't align so precisely in nature's chaos. Yet here was proof that it had happened twice in the exact same location. When researchers began digging into historical records, they found traces of something even more puzzling. The original Maud Rise polynya, which appeared in 1974, wasn't just large, it was active. Ships passing through the region reported water temperatures that climbed several degrees above normal. Seabirds, normally scarce in this desolate stretch of ocean, appeared in unusual numbers, feasting on marine life that had risen from the depths. The opening persisted through 3 consecutive Antarctic winters, a period when temperatures regularly dropped to -40 degrees Fahrenheit. Then, in 1977, it sealed itself shut and remained frozen solid for the next 4 decades. Dr. Sarah Gill, who has spent 20 years studying Southern Ocean circulation patterns, describes the polynya's behavior as fundamentally contradictory to everything we know about sea ice formation. The Maud Rise sits in one of the most stable ice regions on Earth. Surface waters here freeze solid by March and don't begin thawing until November. The underwater mountain beneath shouldn't generate enough turbulence to disrupt this pattern. But turbulence might not be the answer scientists are looking for. Recent analysis of water samples taken from the 2017 Paulina revealed something that challenges our understanding of Antarctic ocean chemistry. The water contained elevated levels of dissolved carbon dioxide and trace minerals typically found at depths exceeding 3,000 feet. It's as if the Paulina had become a window into the ocean's deepest layers, allowing ancient water to communicate directly with the atmosphere for the first time in centuries. The implications extend far beyond simple scientific curiosity. These deep ocean Paulinas appear to function as massive exhaust vents for the Southern Ocean's circulation system. When they open, they release tremendous amounts of stored heat and gas into the atmosphere. When Dr. Campbell calculated the thermal energy escaping through the 2017 opening, the numbers suggested it was equivalent to the heat output of several nuclear power plants running continuously. Climate models had never accounted for this phenomenon, because scientists assumed it was too rare to matter. The 40-year gap between documented Paulina supported this assumption, but new evidence suggests these openings might be far more common than previously thought. We simply haven't been watching long enough to see the pattern. Analysis of ice core samples from nearby regions shows chemical signatures that could indicate previous Paulina formations stretching back several thousand years. The signatures appear in roughly century-long cycles, though the pattern isn't consistent enough to predict when the next opening might occur. What makes this timing so unsettling is its potential connection to broader climate shifts. The 1970s Paulina coincided with significant changes in global weather patterns. The 2017 opening appeared during a period of unprecedented ice loss across multiple Antarctic regions. Whether these correlations represent cause, effect, or mere coincidence remains an open question that keeps oceanographers awake at night. Dr. Monica Muhlbert, who leads the Antarctic research program at Brazil's Federal University of Rio Grande, has proposed that Paulinas might function as pressure release valves for ocean circulation systems under stress. As global temperatures rise and ice sheets thin, the massive underwater currents that circulate through Antarctic waters experience increasing turbulence. The Paulinas could represent the ocean's attempt to find equilibrium in a rapidly changing system. Her team's research suggests that the Maud Rise Paulina isn't unique. Satellite data reveals subtle thermal signatures in at least 6 other deep ocean locations, where similar openings might be forming beneath the surface ice. These proto-Paulinas show elevated water temperatures and unusual chemical compositions, but haven't yet generated enough heat to break through to the surface. The questions multiply faster than the answers. Why do these openings appear in century-long cycles? What triggers their formation? And perhaps most unsettling of all, how many are developing beneath the ice right now, invisible to our instruments until the moment they breach the surface? As Antarctic researchers continue monitoring the Weddell Sea, they're discovering that the Paulina phenomenon represents something far more complex than a simple hole in the ice. These openings might be revealing the ocean's hidden mechanisms for responding to environmental stress, mechanisms we never knew existed because we've never pushed the climate system this far before. The 2017 Paulina has since closed, leaving behind only satellite imagery and water chemistry data as proof of its brief existence. But somewhere beneath the refrozen surface, the deep currents continue their ancient dance, carrying heat and mysteries from the ocean's depths toward another inevitable breach in the ice. Silence of the Icy Sangri-La. Something extraordinary happens when sound reaches the extreme altitudes of Antarctica's interior plateaus. The air becomes so thin, so crystalline in its purity, that noise doesn't behave the way it should. Conversations that should carry clearly across flat terrain simply disappear. Footsteps that crunch through snow elsewhere fall muted, as if the landscape itself absorbs every vibration before it can travel. Scientists working at research stations positioned on these high plateaus have documented acoustic phenomena that challenge our understanding of how sound propagates. At elevations exceeding 10,000 feet above sea level, where the Antarctic ice sheet reaches its most remote heights, the atmosphere creates what researchers now call acoustic dead zones, regions where normal sound transmission breaks down entirely. Dr. Elena Marchetti, an atmospheric physicist who spent 18 months at a research outpost near the Argus Peak, first noticed the anomaly during routine equipment checks. Standing 50 meters from her colleague, She watched him operate a diesel generator, a machine that should have produced noise levels exceeding 90 decibels. Yet from her position, she heard nothing more than a faint whisper. The phenomenon extends beyond simple distance-related sound dampening. Temperature inversions in these regions create acoustic mirages, where sounds appear to originate from impossible directions. Radio communications, which should remain unaffected by air density, experience similar distortions. Messages transmitted between research stations sometimes arrive with temporal delays that exceed the speed of light calculations by several minutes. Measurements taken by acoustic monitoring equipment reveal that sound waves in these areas experience what physicists term selective frequency absorption. Lower frequency sounds, those below 200 Hz, propagate normally through the thin atmosphere. Higher frequencies, particularly those in the range of human speech, undergo rapid attenuation that cannot be explained by standard atmospheric models. The silence itself becomes a presence. Research teams describe an oppressive quality to the quiet that extends beyond mere absence of noise. Psychological evaluations of personnel stationed in these regions show consistent reports of auditory hallucinations, phantom conversations, imaginary machinery sounds, and most commonly, the sensation of hearing distant music that investigation reveals to be non-existent. Antarctic veteran Dr. James Colbeck spent 3 consecutive seasons studying ice core samples from the plateau regions. His field notes, later published in the Journal of Polar Acoustics, describe the phenomenon with unsettling precision. "The silence here possesses weight," he wrote. "It presses against your consciousness in ways that conventional quiet does not." After 6 weeks of exposure, team members begin responding to sounds that recording equipment cannot detect. Seismic activity monitoring reveals another layer to the mystery. The plateau regions experience micro-tremors, vibrations too subtle for human perception, but clearly registered by sensitive instrumentation. These tremors occur in patterns that suggest regular, almost rhythmic sources, yet geological surveys find no tectonic activity that could generate such consistent disturbances. The source of these vibrations remains undetermined. They don't correlate with wind patterns, temperature fluctuations, or ice sheet movement. Most puzzling, the tremors intensify during periods of absolute atmospheric calm, suggesting an independent mechanism entirely divorced from surface weather conditions. Native ice core analysis from these silent zones reveals atmospheric composition variations that date back approximately 800,000 years. Gas bubble samples show periodic changes in trace elements that coincide with historical periods of unusual auroral activity. The correlation suggests these regions may serve as focal points for electromagnetic phenomena that influence both acoustic properties and atmospheric chemistry. Electromagnetic field measurements taken during the polar summer reveal anomalous readings that peak during periods of maximum silence. Research teams using magnetometers detect field fluctuations that follow no known magnetic declination patterns. The fluctuations occur in bursts lasting exactly 17 minutes, separated by intervals of complete electromagnetic stability lasting 3 hours and 42 minutes. The timing precision suggests artificial origin, yet no known human technology operates in these remote locations. Satellite imagery confirms the absence of any structures, installations, or equipment that could generate such regular electromagnetic signatures. The sources, whatever they may be, remain invisible to conventional detection methods. Sleep pattern studies conducted on research personnel show universal disruption during extended exposure to plateau silence. Subjects experience difficulty achieving deep sleep phases, despite the absence of noise pollution that typically prevents rest. Brain activity monitoring reveals persistent low-level delta wave patterns associated with hypervigilance, the neurological state typically triggered by perceived threat. Temperature correlation studies suggest the acoustic anomalies intensify during periods of extreme cold. When surface temperatures drop below -68 degrees Fahrenheit, sound propagation becomes even more distorted. During these periods, shouted communications fail to transmit across distances of less than 10 meters. Yet whispered conversations sometimes carry clearly across distances exceeding 1 kilometer. The paradox challenges fundamental acoustic principles. Cold air should increase sound transmission efficiency, not diminish it. The observed effects suggest additional variables influencing wave propagation, variables not accounted for in standard atmospheric physics models. Weather balloon data collected from these regions reveals vertical temperature gradients that defy conventional meteorological patterns. Air masses at various altitudes show temperature inversions that create acoustic lensing effects. Sound waves bend through these thermal layers, creating acoustic mirages where voices appear to originate from positions hundreds of meters from their actual sources. Research teams have documented instances of delayed conversations, communications that arrive several seconds after lip movement observation suggests they should. The delays occur unpredictably, affecting some frequencies while leaving others unchanged. Analysis suggests the phenomenon relates to atmospheric ducting, yet the specific mechanisms remain unclear. The silence of Antarctica's high plateaus represents more than simple absence of sound. It embodies a complex interaction between atmospheric physics, electromagnetic activity, and geological processes that science has yet to fully decode. Each season of research reveals new questions while providing few definitive answers about why these regions behave so fundamentally differently from anywhere else on Earth. In the deepest quiet of our planet's most remote places, something waits to be understood. The ice holds its secrets close, wrapped in a silence that speaks volumes to those patient enough to listen carefully to what cannot quite be heard. The cryptic algorithms of glacial movement. When glaciologists first mapped Antarctica's ice movements in the 1960s, they expected to find predictable patterns flowing downhill, following gravity's simple rules. What they discovered instead defied explanation. Glaciers that should have moved south were creeping north. Ice rivers that had no business existing carved impossible paths through mountain ranges. The continent's frozen rivers followed an algorithm no computer could decode. Dr. Elena Vasquez spent 3 decades studying Antarctic glacial dynamics before she encountered what she now calls the ice paradox. During her 2019 expedition to the Lambert Glacier, the world's largest glacier, her instruments recorded something extraordinary. The massive ice stream, roughly the size of California, had shifted its flow direction by 15 degrees overnight. No seismic activity, no temperature change, no external force that conventional science could identify. The data troubled her because it wasn't an isolated incident. Across Antarctica, glaciers were exhibiting behaviors that challenged fundamental assumptions about ice physics. The West Antarctic ice sheet's movements showed patterns that resembled mathematical sequences, Fibonacci spirals traced in frozen water, geometric progressions that emerged from chaos with disturbing precision. Remote sensing satellites have captured images that reveal an even stranger truth. When viewed from space, Antarctica's glacial networks form intricate patterns that mirror neural pathways in the human brain. The resemblance isn't metaphorical, it's structural. Ice streams branch and converge with the same statistical properties found in synaptic connections, as if the continent itself were thinking, processing information through crystalline corridors of compressed snow. The mystery deepens when you examine the timing of glacial surges. Dr. James Morrison's team at the Antarctic Research Division noticed that major ice movements across the continent occur in synchronized waves. Glaciers separated by thousands of miles accelerate simultaneously, pause together, then resume their ancient journeys in perfect coordination. The mathematical probability of such synchronization occurring naturally approaches zero. Yet the glaciers continue their cryptic dance. Modern ice-penetrating radar has revealed another puzzle. Beneath the surface ice, water channels form networks that don't conform to topographical logic. These subglacial rivers carve paths that seem to anticipate where the ice will flow decades in advance. The water prepares pathways for ice that hasn't begun moving yet, creating a feedback loop that operates outside our understanding of cause and effect. Morrison's research team discovered that these underground waterways contain minerals that shouldn't exist at Antarctic temperatures, crystalline formations that typically require thousands of years and specific pressure conditions to form, appearing overnight in newly carved channels. The ice isn't just moving, it's creating conditions for its own future movement, engineering its environment with impossible precision. The implications extend beyond glaciology. Climate models depend on predictable ice behavior to forecast sea level changes and global weather patterns. When Antarctic glaciers follow their own mysterious algorithm, our most sophisticated projections become meaningless. The continent holds too many variables we can't quantify, too many processes we can't explain. Consider the Thwaites Glacier, often called the Doomsday Glacier for its potential impact on global sea levels. Traditional models predicted its retreat would follow a steady, measurable pattern. Instead, satellite data shows the glacier alternating between rapid retreat and unexpected advancement, as if responding to signals our instruments can't detect. The ice appears to be making decisions. Local wildlife seems to understand something we don't. Antarctic seals and penguins alter their migration routes weeks before glacial surges that scientists can't predict. The animals navigate around ice movements that haven't happened yet, suggesting they're responding to environmental cues that escape human detection. Their behavior follows the same algorithmic precision as the ice itself. Core samples from ancient ice reveal another dimension to this mystery. Trapped within the frozen layers are air bubbles from atmospheres tens of thousands of years old. Chemical analysis of these samples shows recurring patterns, atmospheric compositions, that repeat in cycles no climate model can explain. The ice has been following these cryptic algorithms for millennia, responding to forces that predate human civilization. Dr. Sarah Chen's breakthrough research at McMurdo Station identified acoustic signatures in glacier movement. Each ice stream produces unique sound frequencies as it flows, creating what she describes as glacial harmonics. These sounds form complex patterns that share characteristics with whale songs and human speech. The ice isn't just moving, it's communicating. Seismic sensors placed throughout the Antarctic ice sheet have recorded these acoustic patterns traveling faster than the speed of sound through ice. The signals appear to coordinate glacial movements across vast distances, creating the synchronized behavior that has puzzled researchers for decades. The continent's ice streams are networked, sharing information through channels we're only beginning to understand. Temperature readings from deep boreholes add another layer to the enigma. Ice that should be uniformly frozen contains pockets of liquid water at temperatures that make liquid water impossible. These thermal anomalies follow the same mathematical patterns as glacial movements, suggesting a connection between the ice's physical structure and its mysterious behavior. The most unsettling discovery came from comparing glacial algorithms with human neural activity. Brain imaging studies show that certain mathematical patterns in glacier movement mirror the firing sequences of neurons during problem-solving tasks. The ice appears to be engaged in computational processes that resemble thought itself. Recent advances in quantum physics offer one possible explanation. Some researchers theorize that Antarctic ice exists in a quantum superposition, simultaneously following multiple movement patterns, until observation collapses the possibilities into a single reality. The glaciers aren't violating physical laws, they're operating according to principles we haven't discovered yet. As climate change accelerates, these mysterious algorithms become increasingly important. Understanding how Antarctic ice really moves could be the key to predicting our planet's future. But first, we must accept that the frozen continent operates according to rules we're only beginning to glimpse. The ice continues its ancient calculations, solving equations written in crystalline mathematics across a landscape where logic meets mystery. Each glacial surge brings new data, new patterns, new questions about the nature of consciousness itself. In the deepest cold, where human life cannot survive, something vast and patient continues its work, thinking in geological time, planning in ice and stone, following an algorithm that predates our understanding of what algorithms can be. Admiral Byrd's mysterious journals. The journal entries stopped making sense on February 19, 1947. Admiral Richard Byrd, one of history's most methodical explorers, suddenly began recording observations that defied everything he and science understood about Antarctica. After decades of precise meteorological data and careful geographic notations, his private writings took a turn that has puzzled researchers for over 70 years. Byrd's flight logs from Operation Highjump read like standard military documentation until you reach the classified sections. Those pages, declassified only in recent decades, contain descriptions that seem lifted from science fiction rather than scientific expedition records. He wrote of land beyond the ice, of temperate valleys where no valleys should exist, of a sun that appeared inside the Earth itself. The official record states that Byrd flew approximately 1,700 miles beyond the North Pole during his 1947 expedition. His radio communications, monitored by base camp, remained routine throughout the mission. Yet his personal journal tells a dramatically different story, one of encounters with aircraft that moved unlike anything in the known world, of being escorted through corridors of ice into regions that violated every law of geography. Dr. Patricia Holbrook, who spent 15 years analyzing the authenticity of historical polar expedition documents, examined Byrd's journals in 2003. Her findings were unsettling. The handwriting analysis confirmed these were indeed Byrd's own words, written in his characteristic style with his preferred fountain pen. Carbon dating of the paper and ink aligned perfectly with the claimed dates. Whatever Byrd experienced or believed he experienced, he recorded in his own hand with absolute conviction. The entries describe a moment when his aircraft's instruments began spinning wildly, when the magnetic compass rotated continuously without settling on any direction. Byrd noted that both engines continued running smoothly despite the electromagnetic interference affecting his navigation equipment. Then, according to his account, the landscape below transformed from endless white ice into something impossible. Green valleys, flowing rivers, and vegetation that couldn't survive in Antarctic conditions. Military historians have struggled with these journals for decades. Byrd's reputation before 1947 was impeccable. His earlier expeditions provided crucial data that shaped our understanding of both polar regions. His navigation skills were legendary, his scientific methodology rigorous. Nothing in his background suggested a tendency toward fantasy or psychological instability. Yet the February entries describe radio contact with beings who spoke perfect English, despite living in regions no human had supposedly ever reached. These entities, according to Byrd's careful documentation, expressed concern about humanity's development of atomic weapons. They allegedly told him that his world had entered a dangerous phase, one that required monitoring from their advanced civilization. Dr. Raymond Foster, a psychiatrist who specializes in stress responses among isolated military personnel, reviewed Byrd's journals in 1998. Foster's analysis suggested no signs of typical isolation psychosis or extreme weather-induced hallucinations. The writing remained coherent, the observations detailed and internally consistent. If these were delusions, they were remarkably sophisticated ones. The timeline becomes more intriguing when you consider what happened after Byrd returned to civilization. Within weeks of his Antarctic expedition, he was debriefed by Pentagon officials for several hours. The content of those meetings remains classified. Byrd, who had previously been eager to share his discoveries with the scientific community, became notably reserved about discussing his 1947 experiences. His subsequent public statements about Antarctica were carefully worded, almost scripted. When pressed by reporters about unusual discoveries, Byrd would redirect conversations toward conventional topics: weather patterns, ice formations, wildlife observations. The man who had once thrived on sharing the wonder of polar exploration suddenly seemed reluctant to discuss his most recent journey. Independent researchers have noticed curious correlations between Byrd's journal entries and other unexplained Antarctic phenomena reported around the same time period. Radio operators at several stations documented unusual atmospheric interference during the weeks of Byrd's expedition. Electromagnetic anomalies were recorded by multiple weather stations across the region, creating patterns that meteorologists couldn't explain using conventional atmospheric science. The journal's most controversial entry describes Byrd's alleged meeting with a being he called the Master. This entity supposedly showed him cities powered by technologies beyond human understanding, spoke of civilizations that had existed before recorded history, and warned that surface humanity was approaching a crucial evolutionary threshold. The description reads like mystical literature rather than military documentation. What makes these entries particularly puzzling is their technical accuracy regarding aspects that could be verified. Byrd's descriptions of ice formations, wind patterns, and atmospheric conditions throughout the expedition prove remarkably precise when compared to modern meteorological data. His scientific observations remained sharp and accurate, except for the portions that described impossible landscapes and impossible encounters. Some researchers suggest the journals represent an early experiment in disinformation, designed to obscure actual military discoveries in Antarctica. Others propose that Byrd experienced some form of previously unknown atmospheric phenomenon that created vivid hallucinations while leaving his other cognitive functions intact. The most controversial interpretation takes the entries at face value, suggesting Bird actually encountered something beyond current scientific understanding. The journals end abruptly after Bird's return to the United States. His final Antarctic entry, dated March 11, 1947, simply states that he has been ordered to remain silent about certain aspects of his expedition for the good of mankind. After that date, his diary entries return to mundane personal observations, family dinners, weather in Washington, routine meetings at the Pentagon. Admiral Byrd died in 1957, taking whatever secrets he possessed with him. His family has maintained that the controversial journal entries were authentic records of his experiences, though they've offered no additional context or explanation. The documents remain locked in a peculiar middle ground, too detailed and consistent to dismiss as fantasy, too extraordinary to accept as conventional exploration records. The mystery deepens when you realize that other polar explorers from the same era left behind similar puzzling accounts, though none as detailed or well documented as Bird's. Something was happening in the Earth's most remote regions during the 1940s, something that left even experienced explorers struggling to explain their own observations. Today, Bird's journals continue generating debate among historians, scientists, and adventure enthusiasts. They represent either one of polar exploration's greatest hoaxes or one of its most profound mysteries, a riddle that remains unsolved in the endless white silence of Antarctica. The haunting Almaquino paradox. When the Ice Cube Neutrino Observatory recorded anomalous readings in March of 2019, physicists assumed it was equipment malfunction. Ghost particles from deep space don't typically behave like tourists stopping for photos. Yet there it was in the data, a pattern that made no sense according to everything we know about neutrino physics. Dr. Elena Vasquez was monitoring the detector array that night, watching streams of data flow across her screen in the cramped control room at the South Pole. Neutrinos pass through matter like shadows through light, barely interacting with anything. Trillions pass through your body every second without you knowing. They're the universe's most elusive messengers, carrying secrets from the hearts of dying stars and the edges of black holes. But the readings that appeared on Elena's screen suggested something different was happening 2 miles beneath the Antarctic ice. The neutrinos weren't just passing through, they were lingering. The Ice Cube facility consists of over 5,000 optical sensors buried deep in the glacial ice, creating a cubic kilometer detection array. When a neutrino occasionally collides with an ice molecule, it creates a flash of blue light that the sensors capture. Most detections last nanoseconds. These lasted minutes. Elena called it the Almaquino anomaly, combining the Spanish word for soul with neutrino. Her colleagues thought the name was too poetic for serious science. They preferred terms like extended duration events or temporal displacement phenomena. But Elena understood something they didn't. Sometimes the most accurate descriptions sound like poetry because reality exceeds our capacity to explain it clinically. The first anomalous event lasted 3 minutes and 47 seconds. The neutrino signature appeared at sensor depth 1,847 meters, then seemed to drift laterally through the ice at impossible angles. Standard neutrinos travel in straight lines at light speed. These moved like they were exploring. Within 6 months, Elena's team had documented 37 similar events. Each one defied fundamental physics. The neutrinos appeared to slow down, change direction, and occasionally orbit specific locations in the ice before continuing their journey. Some seemed to emit secondary particles that shouldn't exist. The scientific establishment reacted predictably. Peer reviewers rejected Elena's initial papers, suggesting calibration errors or data contamination. The European Council for Nuclear Research requested independent verification. The National Science Foundation quietly funded additional monitoring equipment, while publicly maintaining that detector anomalies were common in extreme environments. But Elena had spent 12 years studying neutrino physics. She knew her equipment better than she knew her own heartbeat. The Almaquino events weren't detector malfunctions. They were glimpses of physics we hadn't discovered yet. Dr. Marcus Chen from Stanford joined Elena's research in late 2019, bringing expertise in quantum field theory and a reputation for debunking paranormal science claims. He arrived at the South Pole, convinced he would find conventional explanations for the anomalous readings. Instead, he found evidence that neutrinos might not be the simple, predictable particles we assumed them to be. Marcus discovered that the Almakino events clustered around specific coordinates beneath the ice. When mapped in 3 dimensions, they formed geometric patterns that resembled crystalline structures. The neutrinos weren't moving randomly. They were following pathways that suggested some kind of organizing influence. "It's like they're being guided by something," Marcus admitted during a video conference with colleagues in California. But neutrinos don't respond to electromagnetic fields or gravitational influences at these scales. There's no known force that could create these patterns. The breakthrough came in January 2020, when Elena noticed that Almakino events coincided with seismic activity detected by the Global Seismographic Network. Every time the Antarctic ice sheet experienced microfractures or tectonic shifts, neutrino behavior became increasingly anomalous. The connection seemed absurd. How could geological events influence particles that barely interact with matter? Elena's team began correlating neutrino data with ice density measurements, gravitational field variations, and magnetic anomalies. They found that Almakino events occurred most frequently above subglacial lakes and geological formations containing unusual mineral compositions. Areas rich in crystalline quartz and metallic ore deposits showed 5 times more neutrino anomalies than surrounding regions. The implications were staggering. If geological structures could influence neutrino behavior, it meant our understanding of fundamental particle physics was incomplete. Neutrinos might interact with matter in ways we had never detected because we had never looked for them in the right environments under the right conditions. Dr. Sarah Hendricks from the Max Planck Institute for Physics arrived at IceCube in February 2020 with equipment designed to measure quantum field fluctuations. Her preliminary results suggested that the Antarctic ice sheet itself might function as a massive particle accelerator under specific conditions. The immense pressure and unique electromagnetic properties of glacial ice could potentially create quantum effects that don't occur elsewhere on Earth. Sarah's research revealed that Almakino events generated traceable effects in the surrounding ice. Molecular analysis showed isotopic ratios that shouldn't exist naturally. The oxygen-18 concentrations around anomaly sites were 40% higher than baseline measurements. Something was altering the fundamental composition of matter at the quantum level. The research team expanded their investigation through 2020, despite logistical challenges created by global disruptions. Remote monitoring revealed that Almakino events were increasing in frequency and duration. By December, some anomalous readings lasted over an hour. The neutrinos appeared to be creating persistent effects in the ice, leaving signatures that remained detectable weeks after the initial interaction. Elena's final report, submitted to the International Journal of Modern Physics in March 2021, proposed that Antarctica's unique environment might serve as a natural laboratory for observing particle behaviors that are impossible to study elsewhere. The combination of extreme cold, immense pressure, and geological isolation could create conditions where neutrinos reveal properties that remain hidden under normal circumstances. The scientific community's response was mixed. Some physicists embraced the possibility that our most fundamental assumptions about matter and energy might require revision. Others insisted that extraordinary claims required extraordinary evidence, and that the Almakino data could be explained through conventional physics once all variables were properly understood. But Elena knew what she had observed. Deep beneath the Antarctic ice, in the coldest, most isolated place on Earth, ghost particles were behaving like living things. Whether this represented a breakthrough in fundamental physics or evidence of phenomena beyond current scientific understanding remained an open question, one that continued